Hello and welcome to the presentation of the winners of the 40th anniversary awards for the International Obfuscated Sequence Contest, otherwise known as this time as IOCCC28. Before we get started, let's introduce ourselves. So the person over
Hello.
there, Leo, if you could introduce yourself.
Hi, I'm Leo Brucas. I'm twice the winner of the IOCCC in 1993 and 1995. And after I moved to the United States, it turned out that I lived close enough to London that I became a judge starting from 1998. So here I am since.
And we have a disembodied voice.
Hello,
David,
hello.
would you introduce yourself and tell us a little about yourself?
Yes, I'm David. I'm from Halifax, Nova Scotia, and I do production and music and graphics and stuff.
And David is the author of the music you will hear, as well as the cool graphics, and our producer. So, in case you came by and you say, what's going on? I am Landon Curtin-Ohl. I am a founding judge of the International Obfuscated Sequence Contest. It started back in 1984 when Larry Basil and I were having to debug both the Bourne Shell and the Finger Demon. And we both came out of our office at the same time, kind of complaining about the code, and decided to go on to what was then nec.lang.c in Flame, saying, I don't know how we could actually write code like this. Can anyone write any code that's even worse? And we gave them 5 to 12 bytes, and we got some entries that we awarded the best of. And then in 1985, a year later, Larry came by and said, hey, remember we did that thing with the C contest stuff? Let's do it again, right? So but although we had called it that it was the International Obfuscated Sequence Contest, and we had international things. But what is it? Well, first of all, obfuscate. If you're not familiar with the term, or maybe if English is not your native language, obfuscate means to render, to obscure, to darken. And the goals of the contest are pretty simple: to write the most obscure obfuscated C program within the rules, to show the importance of programming style in an ironic way, to emphasize precarious code by use of negative examples, to stress test compilers' unusual code. And it's not unusual for there be some submissions that cause the compilers to problems, sometimes even core dump. Illustrate some of the subtleties of the C language, and you'll see some very subtle things. You say, I didn't know C did that, because our winning authors do wild things with C. Also, provide a safe forum for poor C code. This is not code you want to put into your production, and it's also have fun with C. So that's been the tradition, and we are happy to start with that. Now, what we're going to do on this show is, after the sort of introductions, we're going to have some general remarks next about IOCCC28. And then we're going to present some winning entries. And then we'll have an intermission. And we present some more winning entries. And we'll have some remarks on the winners. We'll talk about sort of what's next. We will release the source code live and on the website. And after an intermission, thank you, we'll have a Q&A. So without further ado, I guess to talk about IOCCC28 as other contests, we judge the submissions anonymously. So when we get a submission in, we don't know who wrote it. We just see the code, the facts of who's the author and that sort of thing is hidden from us. It is only when we end up selecting these are the winning entries do we then go in and find out who won. So the submissions that don't win the C contest are deleted. And so we never know who wrote it or what. In fact, we kind of purge those things from our mind to focus on the amazing submissions that you will see. We go through a whole multiple rounds of judging. So we start off with a pile of submissions, and we sort of have the ones that will move forward and the ones that will stay behind. And we sort of begin to divide that. Now, as we go forward in further rounds, we go back to the ones left behind and re-examine those again. So a submission is given multiple chances, multiple tries, because sometimes we see something that we don't see before or whatever. So submissions get multiple chances. But at some point, when we end up with a set of stuff staying behind and stuff that's moving forward, we go into the mid rounds where we go into much more detail on the submissions. And then we enter into what we call the final round phase, where before each submission is competing on its own merit. So we're just judging each submission individually. In the final rounds, begin to have submissions compete against each other. And we go through final rounds. In the final round, the ones that are left are the declared winners. The ones that don't make it, left behind, are deleted. And there now, one of the traditions is what people who win the C contest get is recognition. And there's some people that consider, well, it's a considerable badge of honor to have won the International Obfuscated C Code contest. So recognition is what the winners get. So those that don't win are not recognized. They're slightly deleted. Those submissions can be improved upon and come back again. And some have actually gone through several contests before they win. So that's sort of is the general process. But by tradition, we don't say how many submissions were received. That's only known to the judges, not even to David. And
look, it's my understanding that you received like X number and possibly even Y number of submissions this year. So,
well, there's some. There's some mathematical. Go ahead.
No, what I was going to say that early contests in the 80s and early 90s used to publish how many pages were printed to analyze the entries. And, now we don't do that. We don't waste paper anymore. So instead, we could have published the size of the GitHub database at the end of the judging rounds, but we forgot to to see how much it was. But it was in many tens of megabytes as far as I remember.
Yes. And that's moderated by the fact that some entries are big and some entries are small in terms of having auxiliary files. But it's, again, if the winners get recognition, things that don't win don't get recognized. So if your submission doesn't win, don't take it bad because there's a number that were left behind, and we do appreciate the amount of work you put into it. But we have to pick some, and these are coming up for there. By the way, if you could do us a favor, if you're watching on YouTube, if you click that like button, that'll help us. And also, you click subscribe. If you subscribe to a channel, you're not going to get bugged. It's really sort of what you're really saying to YouTube is, I like this channel. Nothing. We don't send out anything. You don't get hassled. It just says, I like this channel. So please consider liking and subscribing. Any other comments before we get ready? I want to talk some general remarks before we get some general remarks about IOCCC28. So the winners were announced for IOCCC27 were finally announced in late 2020. And we had a process by which we would announce who won, but it would take a long time before the code was released. We were going through the winners, testing their own submissions, and it was a frustrating time. And there were two people, Mr. Endo and Oscar Tito, who appealed to us privately saying, hey, folks, get your act together and get the code out faster. And so we retooled the entire website to, first of all, fix lots of typos. We had a number of volunteers that actually fixed bugs in submissions so that our features so they can compile in modern compilers. And we did a bunch of other things to produce tools to make it efficient for us to judge the contest, because Leo and I have between us about a century of C experience, and we are pitted against the submitters who have extraordinarily clever ideas. Every contest, there's new stuff that I didn't know you could do with C that people show that they can do. So we have to do our job to try to keep up with technology. But we did have this 4-year delay between IOCCC28 website rebuild, tools, and the efficiency process. We're now GitHub based. The website you see is actually a rendering of the GitHub repo. has its challenges, but it's also thank you GitHub for hosting us. And so I would say we just in terms of this particular contest, we opened in December 29th, 2024. And it ran till June 5th. So we had a long period when it was open, but we also had this 4-year period of people bent up refining their submissions. And as a result, people had nearly 5 years to perfect their submissions. And it shows because the final judging rounds took a lot longer than any other contest. The number of submissions that made it into the final rounds, and that process was much more than usual. I don't know, Leo, you want to, without revealing how many have won so far, because that's you'll see in a moment. You have any comments about the submissions that we received or the winners?
Well, I was very impressed from the beginning. So the first thing we do, we just look at every submission once and try to compile it and run it. And I was unusually impressed. So
yes.
After a 5-year delay, that's not a surprise, of course.
So those that win, you have achieved a really significant mark in the true hacker rank. And for those whose submissions didn't win, apologize, we can't win everything, but I think you'll see the ones that did win are of high quality. And if your submission didn't win, consider trying again next contest. And next contest won't be in 5 years. It'll be starting this December. Little hint. I guess without further ado, because people have waited nearly 5 years for this thing, shall we do it? Do you think we should?
I think
show them.
I mean, we could go over the history of the C compiler language before we.
Yes. But we're committed. The ones that are in this queue have committed. Yes. There's no switching back to this thing or that thing. We're committed. Right. So let's
do it. Let's do it.
Let's start.
Well, let's find out first, I guess, what the first category is. Let's see. And for our first category, we have the IOCCC prize in murky waters. What does that mean?
It's kind of murky.
Very murky.
Yes, I will say our prizes we have a fun time once we know that it's a winning entry. We then have to try to come up with our own prize there, and we have fun. And this one surprised us. It's a bit murky. And you're probably thinking, is this my submission? Did I have anything with waters or murky? What's going on? But without further ado, let's actually reveal who won the IOCCC prize in murky waters.
And the IOCCC prize in murky waters goes to Adrian Cabo from the United States.
Well, congratulations, Adrian. This is Adrian's fourth C contest win. He had a hat trick in 2013, including an amazing best of show. And this particular thing was a surprise. We, as Leo said, we look at the code, and we looked at this code and said, is this person trolling us? What's, and I say, well, what do you mean? Well, first of all, let's look at how you compile this code. And I will point out here that you'll see is we are going to show you with all warnings turned on and all pedantic turned on. So the most extreme of the set. So these things here you'll see afterwards are ways to essentially silence really pedantic over the top warnings. They're not a detriment to the submission. So in some ways you can sort of ignore that stuff. We mostly compile with GNU 17 at the moment, but there's other submissions that have a different running. And of course, so basically, you just compile the program standard way. So when we looked at this thing in the editor, this is what we saw. So I will invite the chat to look at this piece of code. This is the source code. You see it in this is the VM editor with a nice little colored thing, and figure out what does this program do? Because you look at there, we have this grill that's defined and undefined, and then for some reason it's defined and undefined again. We got this main with this loop down here. You got this thing out here, but that's just a salmon is very yummy. Now, you might say, well, what's going on here? So what does the chat think this code, when compiled, will do?
I don't know what the chat thinks, but I think that they won, and there's a fish, so clearly they were fishing for compliments.
So if we look at next and say, okay, one thing we'll do as well is we'll have Clang format take a look at the code. Because sometimes Clang format people will twist their code. They'll write it in a deceptive way or via this code blob. So Clang format is going to try to untangle it. And when Clang format runs, we actually see that it's not just is very yummy, but several strings contended. Now, you may not be familiar with this U qualifier. Leo, you want to tell them what the U qualifier of a string does?
Yeah, so the capital U qualifier means that this string is supposed to be represented as UTF-32, which means that every Unicode character uses 4 bytes.
Yes. So we saw that Clang added some more empty strings before is very yummy. We also see now that grill is defined with this putchar salmon, right? Now remember, salmon's an array of ints, and putchar outputs the lower byte. But of course, grill is defined and undefined, and we have this loop, which appears to, at first glance, say, it's just say 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9, etc. And again, look at you say, is this person trolling us?
Well, let me
yes.
Let me say, I have my eye on the chat. So anybody have a guess as to what this code might do before we show it? Some people say it's fishy.
Yes.
It is fishy. Let me know when it's safe to move forward. Next one. Or people giving up?
I don't see any guesses, so I guess that means we can show them.
Okay. So we are now submitting, releasing winning entries with a try.sh script, which does the basically run things. It helps you run. You could read our comments and remarks about how to do it, but this is a basic thing of it gives you the easy way to do it. So when you run the try.sh script, it runs the program and it prints, for those that are listening, season salmon fillets with olive oil, lemon juice, garlic, salt, pepper, and then grill over medium heat for 4 to 6 minutes per side until flaky and cooked through.
It's black magic.
And yes, that is a general recipe for cooking salmon. But where did that string come from?
I'm pretty sure from a salmon of doubt.
Because I bet you, unless Adrian's in the chats spoiling the surprise, that people didn't say this thing prints a salmon recipe, because it's very murky. So Leo had the idea, because we're sitting there confused, saying, where did this thing come from? What's going on here? Look back to the entry, look back at Clang format. And then Leo said, let's use cat minus V for Victor. It's an argument to cat that deals with unprintable characters. And this is what you see when you look at the code with cat minus V.
Yes.
So
And here,
go ahead.
Here the magic characters that are used are so-called Unicode tag symbols, which are normally ignored by any editor or text renderer, but when they are represented as 32-bit numbers, the least significant byte of each is the actual ASCII code of the letter, the tag of which they represent. So every paper editor will display them as nothing, but they are present in the string. And if you look at every fourth byte, there will be exactly the letter that needs to be printed. And also, if you look at the define grill, there are two different defines. And it's possible now to include Unicode characters in C identifiers. And
Yes.
identifiers may contain just of the Unicode characters, even the invisible ones.
So that undef grill doesn't do anything at all because grill's never been defined. And if you look now at the main, you see that it has this macro in it, which is part of this thing, causes it to print the loop and then terminate.
It's very sneaky.
The for loop is never printed. The magic occurs in here, which again, if you look at what it does, it prints that message. So definitely, you had us fooled. And it took us a while to figure out where these characters are coming from, and it's a very clever hack, and well done, Adrian.
All right. Well, that being the case, we need to make more prizes not murky, and so let's announce the next category. And the next category is the IOCCC prize in Quasi bjection.
So what's being bjected into what? Yeah,
I don't know. It sounds like a MacGuffin from an episode of Star Trek. If I'm being serious, so I have no idea.
Well, I guess you understand what is a bjection, right? And Elio, you had a really good explanation for that.
A bijective function is a function that for every input produces a unique output. So, and then when this output is given back to the function, it produces its input again. Like, for example, y equals minus x will be a bijection.
So this is a quasi bijection. So that's what it came up with this prize name, but who actually won the prize of quasi bijection?
Well, let's find out.
And the IOCCC prize in quasi bijection goes to Tom PNG from Japan.
And congratulations, Tom PNG, for your first winning IOCCC entry. That's what the author claims their name is. In fact, they have a nice GitHub repo you can look at as well. But let's see how you. Go ahead.
Is it PNG or is it ping? Like,
I call it PNG. Now, Tom PNG might have a different thing.
Fair enough.
This is fortunately it's not Tom GIF. We don't have to worry about that thing.
Right.
PNG is a pretty straightforward pronunciation. But let's look at how you compile it. Now, you will see, by the way, in this case, these lines here, this LD warning thing. This is a macOS feature. Where the linker puts out this warning, essentially saying that the data section, the data block had to be repositioned because of alignment exceeds its maximum. Do you see the maximum alignment stuff? I'm sure there's a way that you could tell the linker to stop saying this. It's kind of annoying. I don't think it's a warning. I think it's actually a notice, but whatever. It is what it is. So there's no impugning thing for the LD stuff if your linker happens to be whine about that. But otherwise, it's a pretty straightforward compile. And this is what the code looks like. So you've got this clue about this thing called vortex. And you look at this thing, you've got this nice set of sort of vortex things in there for this quasi bjection process. Now, if you Clang format it, you'll see there's a whole bunch of comments here. We have a void function here. The main is down here. With some other functions. There's lots of these little comments in here, and you say, because the comments in the Vim editor are printed sort of this teal thing, and you can see the comments have kind of C-like things in them, but they're not actually valid C, and intermixed amongst this set. And so, and of course, there's a large data block here, which is why actually there's two large data blocks here and here. That's one of the reasons why it had basically almost 10,000 squared of objects, which is why the linker had to realign things or move the data section to a better alignment. So you say, well, okay, it's kind of odd. Got these odd comments there. You might say, well, that's just to make the code look pretty, but you'd be wrong. So when we run the program on this IOCCC text and you give it to input, it does the following. It vortexes around and prints out, and that's the result. And if you take that output and feed it back into the program, you get the source back. And if you take the program and feed it into itself, so here it's going to read its own source, what it will do is scramble the top. And now that top is valid C. So the output program is actually valid C that you can compile, and you run the compiled version of its vortex output on data source. It does this. And notice it's a sparkly. It's not a twirly thing, it's a sparkly thing to give you your original source. So again, what you're seeing here is that the normal code does this vortice thing to give you and by the way, you can add an argument, so you can have a password so that it will scramble it in a slightly different way.
So this is essentially so it's essentially like encrypting any data you give it, but if you give it to itself, it makes a new program that does the same thing as the old program, but differently.
Yes. In fact, yep. It doesn't do it in a vortice way, it does it in a sparkly way.
That's very, very strange. Very strange.
So if you were to modify those comments, the resulting vortex of the source code would produce something which is not valid C or is not run correctly. So those comments, besides making it pretty, are also necessary so that when it vortexes itself, it produces a program which doesn't vortex, it does it in a sparkly way, but nevertheless, it is. And so this is what we call very fragile code. Change it in a slightly different way, and you will have to fix the bjection, which will be very difficult. So well done, Tom BNG.
Yeah, that's a really... I like that it animates and stuff, too. That's, like, clever. It's very clever.
Chef's kiss.
We need to move on to the next category. So, let's continue. And unscramble this IOCCC prize in Yiltas. And I gotta tell you, when I typed this word in to my editor, it put up a red squiggly line so fast I think I offended the machine. So I don't even know what you're trying to say here.
Well, this is an international contest.
Yes. Yeah.
And so we get lots of languages, including C. And we've had other programming languages as well masquerading as C, and C masquerades as other programming languages. So it's not unusual to have a word which is not in the dictionary's vocabulary. By the way, again, I'll remind you, if you're winning, if your submission wins, let people know in the chat that your things won, so they congratulate you and such. So, but let's see who won this prize in. I think it's pronounced Yiltas.
Yiltas.
And the IOCCC prize in Yiltas goes to Cody Ferguson from the United States.
So well done, Cody. Cody, this is Cody's fourth International IOCCC contest win. Cody had 2 impressive submissions for 2020, and he continues with this new piece of code, which I would say that the C contest is very honored to have this piece of code. You'll see why. In a CY, see what I said? That's a pun, C pun. We have lots of C puns here. But let's see how you compile Cody's code. Now, you'll see in here that whoops, I'm trying to get this back here. I've lost the ability to, okay, I see what's happened. I no longer see it's not rendering properly, but you'll see up here, this data dict, that gives you a clue that you define this dictionary thing. Otherwise, it's a straightforward compilation.
Okie doke.
And here you see this code flying by. It has an IOCCC I there. It's got some interesting pieces of code that are showing up, and rendering. You can see some use, very interesting use of white space in this piece of code. That's part because of the way the rules work. There's a rule 2A which says it has to be under 4,993 bytes, but we have a tool that counts essentially. Think of it as counts source code, but ignores white space and curly braces and semicolons, and that number has to be 2,503 or less. So people make use of exploiting that rule by putting in white space. When you look at this in the Clang format, one of the things you begin to see is this sort of looks like a translation dictionary. And I will point out to the producer, it's no longer showing the things on the line. I'm drawing lines, but it's not showing me lines there. So trust down there.
I'm guessing you just need to refresh again a couple times.
Let me try to do a refresh and try to refresh again. Like I said, so do I see? Nope. Okay. Well, you'll see down there that, there it is. Okay. It just refreshes enough time. You have to be patient. All right. So you see how you have this alphabet table. And if we look at the next thing here, we see again more functions. It's doing some stuff with regards to case of characters with some interesting translation. We see also another alphabet lookup table. Things relating to the case of alphabetic characters, looking for alphabetic characters to process, and then here we also see there's a function which is obviously opening up the dictionary. There's the thing for defining and processing this dictionary. So as a data dictionary that loads in. And on top of that, then we say, well, what going on? Then finally, you finally end up with a main function down here. So you have a bunch of functions, obviously dealing with the dictionary, dealing with case encoding, lookup table. And what does this accomplish? Well, if you run the try script, I try this. There we go.
Oh, it's going.
And so you translate test, it gets this value. If you give that value, you get test. You type in bear, it gives you these words, and those words goes backwards. Commanding officer gets encoded and decoded this way. Cat. Here's code. Code gets translated to yield toss, and yield toss back to code. Sending code does this. You see the cases there, or code received. You see the case for there. International Obfuscated Contest is able to encode that properly. If you have the letters of the alphabet, it encodes it that way, which decoded back. And enough, if you give the source code to itself, so it's encoding itself, and you get output, which when you decode is almost the same, except there's a new line difference, and a challenge is put out to people to figure out why the difference when it decodes itself. You have a new line, which is, can you explain that? That's a question. But what's going on here is this is essentially the fundamental algorithm that the Navajo code talkers used in the Pacific Theater in World War II. These were gentlemen of high honor and high distinction that operated in the Pacific Theater. And they used their language as a means to send messages over the areas that were extraordinarily difficult for people to understand. At the time that the code talkers did their thing, because outside of the Navajo Nation, there were estimated only 30 people who were fluent in Navajo outside of the Navajo itself. Even other indigenous people in that area could kind of know what they're saying, but not quite. The Navajo language is an extraordinary language. It has full of various cases and subtleties. It's just knowing, because I'm sure I'm not pronouncing Yiltas properly. I apologize. The inflection and the nuances in there that they have is an extraordinarily rich language. And listening to Navajo, if you have no idea what's going on, it's even hard for you to figure out what's a word or let alone what is being said. As a number of the commanding officers in the theater would say, that places, battles like Iwo Jima or Midway would not have been won if it were not for the code talkers doing the stuff. Their accuracy was extraordinary. Again, it was a verbal cipher. Other thing that the code talkers did was they did lots of chatter, not just high valued military secrets, but they also would sometimes transmit some GI's love letter back home. So the fact that you heard a code talker wasn't necessarily that something was up, because they had kept chatting. So they were very, very active in their theater. I had an honor to talk to a gentleman here, a code talker, while he was still alive, and he had some extraordinary stories to talk about of their moments for what they had to put up with in this theater. They were there right on the front line. The enemies in the Pacific Theater sort of were trying to figure out what are these sounds, and someone got the idea that it probably is some Native American, Indigenous American, North American language. They did capture some people that had, that were also indigenous, but they had some slight familiarity with Navajo, but they said they're just talking garbage. It doesn't make sense, and I don't understand it. It was the cipher was only declassified, I think, about 1969, and it remains the only spoken cipher that was never broken in operation, right? And it's only after 9, and then later on they were given. So it was kept highly classified, and later on they were probably unfortunately too late for a number of them, given very high levels of honor. So we're really pleased that the C contest is able to give you the Bates algorithm. By the way, this is the Bates algorithm. Pairs of code talkers that kind of knew each other would develop things on top of the base cipher. So as this gentleman told me, he said, rather than saying, he said, like, for example, umbrella, which I would have to spell out, be long, I would say to my counterpart, I don't want to get wet. And the person says, well, how are you not going to avoid getting wet? And it says, well, I'm using something. Is that something you put on, something you go under, or something you hold in your hand? And the guy says, hold in your hand. They're saying this in Navajo, by the way. And so he says, okay, he wants to say umbrella. So now when he says, I don't want to get wet, I know he says umbrella. So they added on top of the cipher these other personal things that they would do in order to establish rapport. Again, very high honored gentleman. And we're really pleased, Cody, to have this as a winning IOCCC entry.
Very nice. Very nice. Well, that said, we have a lot of other code to talk about. So
there's more winners.
Move on. There's more winners. There's more. So let's continue. We have the IOCCC prize in phased periodicity, which is an interesting title for an award.
Well, you might say it's got its phases.
Well, IOCCC has some phased periodicity as well.
Yes, and that's true. But you got some cycle stuff. You got some phase stuff. So that might give you a hint. Might give the author the hint as to what. But let's actually reveal who won.
The trophy phase.
And the IOCCC prize in phased periodicity goes to Ilya Kurdyukov from Russia.
Congratulations, Ilya. Ilya had had 4 winning winners in 2020. This is Ilya's 5th win, and it's a fun piece of code. So let's look at how you actually compile Ilya's code. And we say again, it's pretty straightforward. Again, remember, it's just this is just doing the maximum optimization stuff, so you can kind of ignore that thing and just say it's a straightforward compile. What are we compiling? Well, this is the code. There it is.
It's very small, compact.
The aficionados may recognize the number 2,551,443. Well, so any guesses what it means?
In the chat?
I seen Ilya in the chat, so know that they're...
he's not spoiling it for us. Well,
and
I'll say that as an astronomer... Go ahead.
You may have seen this number in one of the previous entries very, very long time ago.
Yes. And as an astronomer, I recognize...
I would even say many moons ago.
Yes. This is... and as astronomer, I say, oh, that's something... That's a number of seconds rounded to the nearest second of something. And the answer is, that's the number of seconds in a lunar phase cycle. And in fact, we have, it tells you that because there's the moon with the crescent phase. So Clang format wise, it still is a bit impenetrable because you've got these things. But Leo, you pointed out this thing when we were judging.
Oh, that formula for the circle. What's which coordinates lie within the circle?
And
With the
you can
radius.
see it's going to print either a pound sign or a period. So this thing tells you whether you're dealing with the lit side of the lunar crescent or the unlit side, or you have the new line that gets printed up there. 10 is a new line. And it's nice and recursive. There again, you have these constants. This is a offset for time. So given time that is Unix time based, POSIX based, this is the offset for getting the right phase given the time. And so when you run this piece of code, like for example, the time we prepared these slides, this is what it did. You try .sh and run it. There you see the at that time the moon and its crescent phase. Obviously, if you did it now, it'll be slightly different. I wrote a piece of code to modify the time and step through a lunar month day by day, and this is what it does. So you'll see it run again and again and again. So there's the code where I'm going to run, and you can see it goes through all of the. We're actually going through all the craze fest. When you run it, it'll be accurate to the moon there, but that's essentially is the set again. Those are all the various lunar cycles, and if you did it on a half-day basis, you'd see even more gradients. But it's nice. The previous one, I believe, Leo, when was that? When was that lunar phase?
It was in 2000.
Oh, 2000.
2000, not only, yes. And it uses floating point. So obviously using floating point for astronomical calculations, that's the right way to do. And it used like some trigonometry and inverse trigonometrical functions. So that was nice to have. But this one is a tour de force. It doesn't use any floating point at all. And the question is, what does it do and how?
Yes.
So that's for you to figure out.
You could figure out. We're not going to completely spoil every one of these, but well done, Yulia. That was a nice. Again, it's difficult to have a small program that's compact because you've got to really make very careful use of your characters and having your layered obfuscation. And there's more to it than we've just told you. We invite you to look at the code even more and have fun with it. So,
well, that was fun. I like that. I think it's time, though. We got to go on to the next phase. Next.
Let's go into the cycle of who's the new winner or new winning.
Well, next we have the IOCCC prize in creative interpretation. Which doesn't really give you a lot to go on, I gotta say. Like it's an interesting name, but I don't know.
Every entry is a creative interpretation.
Yeah, I could come up with a lot of creative interpretations, but I don't know what this one is.
Well, we were creative in interpreting this code, which has been quite impressive. So, but who won the prize in creative interpretation for IOCCC28?
Out.
And the IOCCC prize in creative interpretation goes to Sandro Maffiodo from Italy.
Well done, Sandro. This is Sandro's third International Cyclonic Contest win. And he had some very fun stuff back in 2014. So 10 years later, he comes out with another winner. Well done. This is a very fun piece of code, I'll have to say. And we're quite pleased to see it. Let's see how you actually compile. And you'll see that it actually we had to do a number of turning off of various warnings. Again, when you go into this all warning pedantic mode. He also included several things on the command line, implicit includes, but otherwise a straightforward piece of command line to compile the code. And this is what the code looked like. That's the source code.
It looks like a boot coming dangerously near the edge of a steep step.
Again, this is creative interpretation. I saw this as like one of those old manuscripts from a monastery where the monk would take the first letter, which is a J, and sort of make it nice and fancy. The first letter of stuff. That was my interpretation. It starts off with this fancy J. But we'll see. Let's look at it from a claim format perspective. And you see we've done in multiple columns here, and you see it doesn't really help as much. One of the things in particular is you got these macros up here with parentheses that causes the formatter to be concerned because he had all these dangly, these things in red, these dangly open parens. But you can see through this set that it has a wide number of functions. It does eventually get down to the main is down here. So lots of functions, lots of macros, really quite twisted in its code. But the question is, well, what does this do? You run a try script and it says, let's go. And you give it some JavaScript and it prints some stuff, gives some other JavaScript and does some more things, some more JavaScript, some test code, some test cases, and even a JavaScript to do Fibonacci. So this is a JavaScript interpreter. It's a very creative way to interpret JavaScript. As you see, it does a rich set of JavaScript, passes all these very stringent tests. And again, you might say, well, the J that was in the source code stood for JavaScript, like a monastery parchment.
I see.
And it is written in C, and it's really compact, and a creative way to interpret JavaScript in a very accurate way.
So, well, we have seen many interpreters over the years, and BASIC and Forth, and Lisp and Brain, this interpreter is a good addition to the compendium of the IOCCC interpreters so far. Thank you very much, Sandro.
Yes, well done, well done. So, with that, shall we see what shall we continue?
Yeah, so let's find out what our next category is.
Continuing on.
We have the IOCCC prize in art restoration. I've done a bit of art restoration before.
Yes. So we took a bit of artistic license with this prize, but I think you'll agree it's apt.
Well, let's find out who won before we talk about it.
And the IOCCC prize in art restoration goes to Ilya Kurdyukov from Russia.
Congratulations, Ilya, for your second win of the night and your sixth win overall. This is a fun piece of code which you actually might make use of. And you'll see why in just a moment. See why. We have to get the C puns in there somehow. But yeah, let's look at the source code. Actually, how you compile. And so it makes use of libjpeg. So these are basically stuff I had to use to find the library and find the include file. So you have to have libjpeg, the library installed as well as the development part of the libjpeg, the header files. It makes use of those services. And the source code looks like this. Now, I first thought this was like one of those SD cards that had the notch in it, like those micro SD you stick in your camera. But someone else had a more accurate thing of what this code is shaped like.
Are you there,
Leo?
Kevin?
I think you had a guess.
No,
Yes.
yeah.
Okay.
This looked like an art restorer workbench. So the kind of nice inclined plane to work on the art piece, and the shelf for all the tools. So we'll see what it does.
Looking from the side. So
yes.
Now if you go and look at it in a Clang format, you'll find that it does have a main function here, a single main function. And all the stuff here is these macros, right? So it's a heavily macroed stuff. You might say that these macros are kind of like functions, but inline functions to do some fairly heavy magic. But there's some fairly heavy magic here, but also this is where a lot of magic occurs as well. There's some reading of stuff, setting up things, and producing results. But there's some heavy magic going on in these loops. Again, a single main function with some fairly complicated macros that are quite just twisted. And if you start getting the C processor to unravel those macros, it turns into an amazing piece of code. So what does it do? Well, if you give it a JPEG input, you get some output. And when you look at that output, you see this. So on the left-hand side was the original input, and the right side is the actual cleaned up. So here you can see the original thing that had all these JPEG artifacts, and it's not showing there. I'll try again.
No, not there.
You can see that those JPEG artifacts, right? And the result is the output as a cleaned up JPEG.
Yeah, for people watching on the phones, it will be hard to see. But trust me, the number of artifacts is greatly reduced. Yeah.
Here's another one where we get another JPEG input that has a low quality, and the output is greatly improved. So we take here again the set. You can see in this region that there's like around these letters, there are all these artifacts that are there that when you look at this spot, it's cleaned up greatly. So it does quite a bit of a good job of reducing. Here's another case where we take a low quality JPEG. In this particular case, here is the input here, and this is the output. And Leo, going to explain what that image is. That's something you made.
I've computed the difference between the original quality 24 image and the final restored image, and these differences are enhanced by brightness enhanced. So this, you can see that all the corrections applied were mostly at the boundaries of these little 8x8 JPEG squares. And interestingly, that some of the squares, one is almost black, so it didn't need any correction. And at the bottom right, most of them were very much corrected, mostly for the blue. So, well, that's some interesting processes going on in this program, particularly depending on the color of the square. That's interesting.
All it's missing now is a monthly subscription.
Right.
Yes.
Yeah,
this is completely free to use, and it is released under Creative Commons, so you can use it. You can even use it in applications that are commercial applications. It's a nice algorithm, making use of it uses the JPEG stuff to manipulate and to produce, but the the algorithm for noise reduction is in that very small, compact piece of C code.
Very, very cool. We have more, though. More to see.
Let's continue. Continuing on.
And what do we have next? We have the IOCCC. Nice accent, eh? Word?
So I've had trying to learn how to pronounce it properly.
Pronounced eh?
As a Yank, I would say A, but that's not A.
No, you didn't know it's not A. You gotta say A properly, eh?
A. Yes.
And look, I don't even know why you're saying it, eh? Because this is supposed to be about C.
So yeah, it is at about C, A.
Oh, I thought it's about C, eh? But I thought it was, oh boy. C-A-N-A-D-A?
Yes. So but maybe we should spare the pronunciation and see who won this. Eh?
Yeah, let's see, eh?
And the IOCCC Nice Accent A award goes to Anthony C. Howe from Canada.
Well done, Anthony C. How your middle name is appropriate for this contest. This is Anthony's, I believe, 7th International Obfuscated Cyclonic contest win. He's a longtime champion going back to the early 1990s, and otherwise he is known as Sir Wumpus. And by the way, if you're in the chat, let people know this is your winning entry, because this is a fun. We had a lot of fun with this submission and now winning entry. Let's see how you compile Anthony C. Howe's code, eh? So when you actually compile this thing, you get some defining of some parameters up here, a buffer size, a mode, a X open source thing. You can include a bunch of header files, a whole bunch of header files. You can also make use of unsigned chars. You make the source code nice and small. But also has a cute thing where even though we are required to create prog.c to create prog, it actually a part of the build says to rename or copy it to a program called A. So what does it do? And the answer is, but let's look at the source code first. I'm sorry. And you can see it's got some weird, interesting characters. I know it's flying by, but if you might not catch it on the first glance. So I went and printed what would be the non-traditional characters, things that are not classic ASCII. And you see it's got some interesting lines. So you have to be careful about the accents, because you see something that looks like an O. It might have an O with a little accent on it. But also has other language characters. It even has this fun little emoji function here too, which is, I think, is pretty interesting. So it borrows a number of characters there, where to understand the source code, you have to have the right accent, A or E.
Yeah, and if you look closely, you will see that there are two characters that look identical. That the Greek theta and the Cyrillic F that look identical on the screen, but they are different Unicode characters. So they are so-called confusable, and the domain names tend to prohibit confusables to avoid spoofing, but, well, the C language is catering to the obfuscators, so it allows them.
Yes. So it is a very interesting, the accent, you have to have the proper accent to understand this source code. So what does it do? Well, if you look at here, so here's, for example, a cute little void, function returns void. That's even a flame emoji that I thought was just really kind of fun. It obviously clears something and sets Z to 0. Why it's called flame? Because Anthony, see how it, I think it amused him, or maybe there's some meaning to the fact that it's the flame emoji.
Yes, this code is fire. That's why it won.
Yes. So I'm back to here, and I need to clear this because there it is. I'm sorry. Can you go back? It is suffering from there. Yeah. So here's other bits of code here. You can see again, you've got this bit of a set of pointers of functions, and again, you have to be careful about these things as to what's what, and have the proper Unicode characters to understand it properly. So what this does is this is a sort of a mini VI like editor, right? And you can do up, down, left, right, or page up, down, left, right. You can go forward and backwards in words. You can go to a column. You can search for a regular expression, go to the next column. You can go to line numbers, toggle selection, delete with a motion, or yank and paste. You can insert a character before the cursor. You can toggle undos. Of course, you can write and quit. So it has a number of standard functions you would have in VI. Here's a little thing where we actually edit a copy of the source code. And so we edit foo, and here you can see where you can move down characters, move characters or words on the side. We can search for A followed by B and find it, and then delete to a marker. And then of course we can turn around and write that out to a file and do a diff, and we see in fact it did exactly that. It actually did the proper editing, removing that stuff. So it's a remarkably functional piece of code for a mini editor in a very small number of bytes. That's, I think, is probably the most impressive part, is just how much power Anthony C. Howe was able to put into that small C program.
Indeed. And next we need to find out what the next category is. So,
because there's more.
There is.
Let's continue.
We have the IOCCC prize in linguistic arithmetic.
So I know
about computational linguistics, but that's something completely different.
Yes, they both end in tick, but it is a nice fact that these two words are the same size. We have fun trying to figure out what the prize is. But you may be sitting there thinking, was my submission linguistic and arithmetic? And, well, without further ado, let's see who won this prize.
And the IOCCC prize in linguistic arithmetic goes to Andrew Kramer from the United States.
Well done, Andrew. This is Andrew's first winning IOCCC entry. It is a really fun submission, and you've been congratulated for your first winning entry. We hope to see you again in future contests. And without further ado, let's look to see how you actually compile Andrew's code. And here we see, again, it's a straightforward, just compile. And when you do that, this is the code you compile. And so you look at this thing and you see that looks like a calculator. There's these buttons here, functional calculator, but the display has words rather than numbers. That gives you a little clue as to what's going on. So if you look at it in Clang, you find this here. The main function is down here in this particular. This is a particularly fun loop where a number of the magic goes on, and you see there's no words other than in a comment here, and that was for the purpose of showing you that calculator-like thing with a display. And so this is where that's where the magic occurs in this section. And the question is, well, what does it do? Well, in the try script, if you run the program and give it the value 2, it TWO, it prints 2. If you say 2 plus 2 minus 1, you give it 3. If you say, and your arguments are 8 trillion divided by 14 million and 7 plus 156, it does that computation. So this program, you give it words, and the words can be the digits, or like 13 or 1,000 or million. It does minus and add, subtract, multiply, divide. It does all those calculations, taking the words and performing arithmetic. And I'll mention that's actually spelled correctly because for English speakers, you can remember how to spell arithmetic because it's a rat in the house may eat the ice cream. In this particular case, the ice cream was definitely yummy.
That's a pretty cool entry. I like it when the entries do what they look like. It always makes it interesting.
Yes. It was well done. Good source layout. Thank you, Andrew.
Shall we move on to the next category?
Let's continue, shall we? Because there's more.
Well, now we have the IOCCC prize in Pentagramology, and I can only assume that somebody has figured out a way to summon demons with C code.
Yeah. They're devils. And you see the words demon and devil are all 5-letter words, if you know what I mean.
Yes. And Penta is a 5-letter word as well. So, but without further ado, who won the prize in Pentagramology? Who is the winner?
And the IOCCC prize in Pentagramology goes to Dave Burton from the United States.
Well done, Dave. This is, this Dave has won consistently from 2015 on, and this is his 6th win. I have it on good authority that Dave is currently about 10 kilometers above the surface of the Earth, assuming that the flight left on time. So, Dave, I would suggest you let the flight attendants know that you need to celebrate. Maybe they have some champagne that you could be given to celebrate what is a really interesting piece of code. This is a fun piece of code. And so let's look at, first of all, how you compile Dave's code. And here we see that, again, ignoring that annoying warning from the linker, it's a straightforward compile, but you are saying photo by source. It has some other auxiliary things, so that we judge it based upon what prog.c does, but he supplies some other pieces of code which did some things such as taking the dictionary and doing some processing on it with these auxiliary pieces of code. And you say, well, what does that do? And This is a piece of code. This is what it looks like. This is the source code. A little bit, there's a hint here that says Wordle. And for those that are familiar with that game, it looks like a Wordle sheet. And for those that aren't familiar with Wordle, it's a game. This, by the way, this is what the source code looks like. Doesn't really help you that much in understanding. It does have a main function down here with lots of other side functions and some interesting sort of constants out there. This is a fairly twisted set of functions that call themselves for doing a very interesting algorithm. I also particularly like this ability to return X, Y, Z, Z, Y. That was a nice little touch.
So what do we got here, though? Yeah.
I'm having to reload.
Oh, okay. Well, I will move forward for you while you're reloading.
So the Wordle things has these sort of three phases. You're given 5 letters. It'll put green if it turns out that you have the right word in the correct spot, or if it's you give the right letter in the correct spot. If it's the right letter but in the wrong spot, it's yellow. Otherwise, it's black. And the next one here, because I may have to reload this browser, and I can't clear the set. So here's a case where you type in the word windy, say that's going to be stuff, and you put on the other side. This was the New York Times, and it says, "Oh, you have a black, yellow, yellow, black." So the yellow letters were correct, but in the wrong spot. And so it says, try nadir. So we type in nadir, and it comes back and it says, oh, we've got yellow, black, green, green, black. So you enter that into the code, and it comes back and says, oh, I got this solved. There it is. It is done the undid. You type in undid, and the New York Times puzzle says impressive, right? It worked out quite well.
Yeah, that's pretty handy. So, like, how accurate is it? Do you think is it going to do that like in 3 all the time? How's it work?
Oh, yeah. Well, there are 2 ways to play Wordle. Well, one is so-called light mode, where you can type any word at any time. And the other is hard mode, where you have to type the word that is consistent with the previous clue. So this entry plays the hard mode. That, of course, makes it hard to win, because you can fall into so-called hard mode trap. So if there are very many words that, let's say, end with the same ending, then you may have to repeat the same ending over and over, trying to guess the one remaining letter. You can have like a batch and catch and hatch and patch. And, well, there is potentially that 6 tries will not be enough. Well, this program plays that hard mode, and it tries to minimize the number of tries, but in a very rare occasion, it may have to use more than 6. So if you're trying to maintain your streak, then you may have to think harder. But if you try to minimize the average number of tries to win, that this program is your guy.
Yeah. And so I say it is, I guess there's different strategies for Wordle players. And this one gives you at least one of the strategies, which is, as you say, optimizing for the minimum number. But as you say, there's in the description, there's a sort of a population set where you look over the full dictionary, and you'll find that there's a small percentage which will go beyond 6. It'll solve it, but the New York Times only gives you 6 tries. And if you're really interested in trying to do the minimum number, this does a really good job of that. So well done, Dave. This is a fun thing for those Wordle stuff. It's encoding that sort of aggressive algorithm for those that want to try. And as the New York Times says, this one is quite impressive.
I don't know if Wordle has prizes, but I know we do. So we should take a look at the next category, which is...
let's continue.
Yes, the IOCCC prize in perfect timing.
Well, this is kind of perfect timing to introduce this prize, don't you think?
I think we can do that. Let's bring down this trophy.
Who won?
And the IOCCC prize in perfect timing goes to Nicholas Carlini from the United States.
And this is Nicholas's second win on IOCC, winning entry. And the first one, and back in 2020, was the best of show. That was an amazing abuse of libc. You should check that out. But this one is particularly impressive, and I think it has a perfect timing for what it does. So the question becomes, well, what does it do? Let's see how you compile this code. Straightforward. Now it does have that data thing, but that's a linker problem, so it's a pretty straightforward compile. If you look at the code, you've got starts off with some includes and some defines, and defines int as underscore. And then you got this block of characters with control Ks and As and other things there. It's sort of like this encoding of something.
Notice that how that encoding uses creatively the curly braces, spaces, and semicolons to minimize the count of useful characters in the program. So it kind of abuse of the character count.
Yes, the rule 2b, which uses IOCC size, which the original author was Anthony Howitt won this time as well, considers white space and curly braces and semicolons as sort of syntactic stuff, and so it doesn't count against you if you use those characters. So Nicholas, of course, it still has to be under 4,903 bytes. You just can't do infinite curly braces. But Nicholas made fair use of that to produce this interesting string. Going further, you get this code blob of stuff. And you say, well, what does this look like? Clang formatted, here is that string. And you can see in this set that we have this these functions. Here's the main function here, returning an int. And you have this other two other auxiliary functions on the side. And it again, without understanding what that string is, it's hard to understand what is this thing doing, because it's got this sort of logic which it isn't apparent why. So if you pile and run the program, first of all, you need to be patient. This particular example is of a calculator where it took about on a fast machine, it takes about 75 seconds per operation. So you see that it does a 5 and a plus, a 3 and a minus produces 2, dot a sum, and the s is a square root. You get the square root there. And you say, well, okay, so you've got some slow calculator. What's the deal, right? Here's another case of a Fibonacci program. Again, you look at this stuff, you see this is just a bunch of strange kind of binary. And by the way, there's an interesting little feature. The zeros get turned into spaces. We will have a challenge for somebody to fix the bug that's in fib.bin going on. But again, it does the correct Fibonacci calculation. It takes about 17 seconds per Fibonacci number. And you say, well, that seems like an awful lot of time. what could it possibly be doing? This is an emulation of the Intel 4004 microprocessor, the world's first microprocessor. It's emulating at, I believe, is the gate level. So that weird character string is an encoding of the gate logic of the entire chip. And this program goes through the logic flow for this particular chip. The original target for this Intel chip is this calculator, the BusyCom, that had a 4-function calculator. It had a square root. That was the square root key over there, as well as a register and so forth. And the inside the circuit board of this calculator was this. So here is the 4004 chip with a bunch of auxiliary chips on the side. I know, Leo, you want to talk about why you thought the perfect timing was a perfect prize for this?
Yeah.
Perfect.
Yeah. So if you look at the image of the calculator, it didn't have an LCD display or LED display for that matter, or a plasma display. It had a drum printer that printed the digits. And to print digits on the drum printer, you have to synchronize the moment where the hammer strikes the drum with the exact character or a digit that is exactly beneath the hammer. So, and that requires a special kind of a simulator. In addition to simulating the chip, you'll have to simulate the timing of the drum and strike the proper hammers at the proper time. So, and well, of course, people will be very interested in what happens if you try to divide by 0. Well, I've tried that, and it does print a row of periods, the same way as the original calculator did. So it didn't have an E character on the side as current calculators do.
And the 4004, this was the first target application for this 4004 processor. The first industrial application was a 5-way intersection in Hayward, California, where the lights had to synchronize, like it was like Mod, Mission, E Street, D, and I think also I think it was El Camino as well, or Foothill, right? And that was a complex light application. It also had included things such as if one of the bulbs burnt out, so the algorithm knew that light was going to be displayed and went and moved a whole 5-way intersection into a safe mode. That particular light sequence actually was online for almost 30 years. I had the privilege of actually seeing the chip on the circuit board sort of similar to this. And it ran for many years. It was only when the need for having a emergency vehicle like an ambulance, they have a certain flashing sequence that could turn the intersection to let the ambulance through that they eventually retired the chip. So well done on the timing. To check out, because it has to emulate some of this other systems as well as the 4004 chip. Really quite a masterful piece of emulation. We've had chip emulators before, but none of them are, I think, as challenging as this world's first microprocessor.
That's a lot of fun. That is.
Yeah.
But we have the perfect timing to look at another prize, I think.
Because there's another winner.
That's right.
Let's continue.
Well, we have the IOCCC prize in sound coding, which I thought all of the previous entries had some pretty sound coding, so I don't know.
I don't know. I mean, in some ways, you might say that the obfuscated C is not sound coding, but they have to work. So in some ways, it is sound in its coding. And so you might think thinking.
C is a numerical node after all.
It's true. It's true. Well, let's find out. Let's find out what makes this one more sound than the others.
Who won this prize in sound coding?
And the IOCCC prize in sound coding goes to _Strad from Denmark.
Well done, Anders. This was Anders' first IOCCC win. It is a very interesting piece of code, but let's see how you compile Anders' coding. And we see it's a very straightforward thing. It does ask you to have the math library linked in. But otherwise, a pretty straightforward compile line. And the code looks like this. Bunch of functions, a bunch of interesting stuff that goes forward, and some interesting little squiggles and parentheses and so forth to finish. If you look at have Clang try to format it, you get something that looks a little bit better. There is this large main function down here that makes use of these auxiliary functions. There is this very interesting macro as well that does some interesting magic. But you look around here, you see it does have a random function going on here, which is kind of interesting use because of considering what it does. So
what does it do?
And see. Well, for this thing, one has to be certainly patient. But when you start, it says just a moment, 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 just a moment. And after those moments,
Well, I can see why that was sound coding, Landon.
yes, it is interesting that this particular thing, that entire thing was synthesized with that piece of code. There's some interesting, the kick drums, and there's some, hi-hats there, and has a snare drum. There's a whole frequency modulus synthesis for that wonderful bass.
I quite like the bass line.
Yeah. He used another program to generate some of the constants that were necessary there. It's actually is a pretty interesting set of stuff. It produced a 256 kilohertz aliasing free waveforms that is quite a nice little beat there, don't you think?
I think so. I quite like it. I think yeah. It was caught in my head for a little bit after I heard it.
Yes, and so each layer is an interesting thing to add on to those instruments that are, again, entirely synthesized in that piece of code with some very important constants there that, of course, drive the results. So Well done. I think it's quite sound in your coding.
I can't disagree with that. I think, though, that we need to move on to another award.
Let's continue, semicolon.
And this is the IOCCC Best One-Liner Classic.
Yes. The Best One-Liner is a long tradition in the C contest. We've had this awarded many times over the years. And the Best One-Liner is a one-line piece of code. And Lee and I have sort of said that 140 characters is kind of the limit for, we'd like to see less than one-liner. So you only have maybe about 100 characters to do something amazing. So your code has to be dense, and you need more than just one trick. It's not just a single trick there. You don't have a lot of luxury for tables and other things. So you have to be very judicious in your characters to do something impressive in one line. It's one of the most difficult categories to try to compete in. And the person who did it very successfully. So who won the tradition of Best One-Liner?
And the IOCCC Best One-Liner is by Stephen Dolan from Ireland.
Well done, Stephen. Your first win. I was looking at this also the first time we've had a winning category from the Republic of Ireland. And you can see the piece of code there, the one line. Although it's missing the second line, I think it's missing the second line there.
Yeah.
Oh, let me see if there's a reason for that.
One moment, as I say, this is live theater, so you can look at the first half forward. But we have it as another thing too. If we can't see this particular thing, we can see it next.
You know what? It's okay. I think I have a solution, because I really liked the bass line. I really liked the bass line from that last song, and it doesn't change. It doesn't change. So I decided to change it a little bit and build our intermission on top of it. And
we're ready for an intermission.
Yeah, I will put up the
P break.
Yes, a C break. We will go to intermission. We will give them both lines of code, and I'll leave them with a reinterpretation of Anders' song.
You'll see the four source, the single line split into two shown, and your job is to look at that piece of code, and by the end of the break, see if you can figure out what it does without typing in and compiling. And even then, you might not figure out what it does. So time to take a break and enjoy the wonderful graphics that David has done, as well as the theme. I believe it's called on Cecil, based on Anders' theme or something like that is his title of this. Well, that was Cecil Swings Anders Bass by our one and only David, using the bass theme of the previous winning entry. And the cat on the side is known as Cecil C Cat.
Yeah, that's Cecil.
And so that was a Cecil Swings there. So we asked you, what does the following single line of C code do? And we split it into 2 lines so you can see it a little better. And the question is, does the chat have any idea as to what this might do? Was there any guesses?
I'm going to investigate the chat right now. Let's see. Somebody says, okay, creates an image from Sebastian Mackey. And they said 80 pixels wide, someone said.
Yes. Yes.
We see control plus does not increase. Oh, okay. That's somebody talking about something else. Let's see. Where is the Z initialized? I think that's as far as they've gotten. They seem to know that it makes an image, though.
Yes. And that's a pretty good guess. If you talk about let's talk about going forward and seeing how you compile this one-liner. You need to move forward because I'll try to reload again. Do a next. My next is not functioning.
I will do that for you. Bear with me just a moment while I switch over to there. And you can do a refresh on your end. Let's see.
Gives you a little bit of chance to see what this code might do. Okay, so here is how you compile this person's code. And it is, again, congratulations, Stephen, for your first winning entry. It also is the first entry from we've received from the Republic of Ireland. And as you can see from the code, it does include a scenario. I believe we now have, if I switch over to here, and there I got the control back. So here's the one line, again, as we saw it, the source, and people sort of honed in on this part to say that's an image 80 by 80, which you're correct. But let's look at this. Let's dive into this piece of code a little bit more. So when you run the code, it reads in 10 hex characters on start input and produces an image. And this is an example of some of the images. In particular, look at this one here. This one here is when you take the source code and you MD5 hash it, and you feed the MD5 hash as input to the source code, it prints out C, which is an interesting thing, and how it actually manages to do that, how the MD5 hash of the source produces an image that says C. That's another bit of magic that's going on here that we quite like. So when you Clang format it, what you'll see is you got this for loop with this putchar expression. And so you got an initializer, the terminator, and the iterator, and it's printing out these characters. Okay, so you say, well, what is it? Well, let's take, here is the original code as Clang did, and let's format it a bit more. Let's undo the for loop so that we have essentially these preconditions of printing out a P1 8080, which is saying we're printing out this particular black and white image that is 80 by 80, and then it scans 10 hex characters on input, and it outputs this. That output is of the image, but it's not clear that it's outputting in the characters for an image. So let's go and dive a little bit further into the set. When you try to compile this, you'll get these warnings about operator present. That's not a valid, it's nothing, but it's saying, hey, there's some operator present you want to be aware of. So we can go and actually, and you'll see here's the original image, and we replace it with something so that you don't have the warnings. And but again, it still seems to be pretty obscure what's going on. So we'll do another iteration. We'll take that expression that was here and break it into several sub-expressions. In particular, this thing we call now W. If W is 0, V gets to be 1. Otherwise, it's 0. And V is then XORed with 49. The other side of the coin of this if, because this is if around whether X is less than 5 or more. And the other side of that if is a new line. So it's printing characters, or depending on if X is less than 5, prints a new line. And here's the iterator. So let's break this down a little bit more. And we see that we can turn it back into a for loop, because that iterator, or the terminator of the for loop, when that becomes 0, so the for loop ends, is when Z becomes 6480. And Z is merely being incremented through the for loop. We put it up here now, and this X is being computed. We also can see now what's happening is that the W expression is taking this complicated thing here, and depending on whether W is 0 or 1, we'll put out a ASCII 0 or ASCII 1, dealing with either foreground or background image, which is going to be a black or a white pixel with the new lines on this side. So doing a little bit more, if you take a look at the output, you'll see the P1 saying the type of image. You'll see the 80 by 80 showing you that it's 80 rows, 80 columns. And then we see these blocks that occur. Those are those pixels you saw, the black or white pixels, showing you what is done based upon the input. Now, if you go further and look at the code, you say, okay, we now know it's a PBM because of the P1. We know we have this block size of 8. We know that we have these 80 by 80 things, so we can start to put in some constants. So these are less magic numbers and more printing out the rows and columns, going through all the rows, all the line lengths, all the characters. We know now that this X less than 5 has to do with this half line block value. And W now can be further. So again, W being a 0, 1 or new line, depending on whether you're in the below the half blocks or not. If you go further and look at the coordinate system he's developed, there's sort of these 8 by 8 blocks that you see here. You can think of a y-axis down the side where the things here, you got less than 0 or more than 0, so that when it goes off to when the block number goes to 5, then it'll print a new line. So that's how he's able to stop it at 80 characters, because the block number advances. The block number is an 8 by 8. When it gets to 5, it's time for new line and reset. So if we look farther into his code, we now have the notion of what's going on with regards to computing the block number, how it actually decides based upon computing Y and W as to whether or not it is going to print out a foreground or background character or do a new line.
The chat is saying somewhere out there, Landon, some AI training scraper is burning.
Yes. And if you go a little bit farther, what you'll see is this. So we've actually turned around and said, okay, we know it's a block number, so we can compute the block number here and use these expressions for W, right? Either if you're on the left side or right side of that axis, you'll either do the first expression or second expression. So when you get W, then you know whether W is going to be a 0 pixel or 1 pixel, or if you're beyond the half lock store, because remember the 0 coordinate was in the middle, on the 0 axis coordinate, a Y axis in the middle. So if it's beyond the edge, then you get a new line. So the main magic, and we'll do a little bit more here, just a little bit more to show you. The main magic is that you either have a left side expression or a right side expression to print the black or white pixel, and you have the new line to terminate the line. So we've taken that single line and broken it there. Now we have limited time on this show. It's long enough as it is. So one of the things your job is going to be to figure out is what in the heck is that expression? How does that expression take G, which is read in on input, and turn that into ones or zeros? And moreover, how does the MD5 hash of the source code produce an image that has C on it? That's for you to decide.
Because it's not symmetrical.
You have to see what you can find out.
Indeed, and we're going to have to see what comes next.
Yes. Yeah. But well done, Stephen. Brilliant one-liner.
Very fun.
Very difficult to do. Very well executed. Well done.
Well,
let's continue.
Indeed. We have the IOCCC prize in Z3, but I'm going to call it Z3.
And because my ABCs were taught to me by a Kiwi, not the fruit, but the person living in New Zealand, I learned it as Z as well. So I have to remember sometimes, and not talking in my current country, to say Z because people say Z. What's that? Yeah, it's called zebra for a reason, or New Zealand, isn't that right? I think that's
I think it's about time that we educate everybody on who won the prize.
Yes.
Let's find out.
And the IOCCC prize in Z3 goes to Christopher Mills from the United States.
Well done, Christopher. Christopher has a long streak of wins throughout the contest, and this is certainly a fine addition to his set of stuff. I think is his 8th win on the contest overall. And let's see how you compile it. By the way, I'll mention Z3. The Z is the mathematical thing talking about essentially the non-negative integers, but it's subscript 3, not in free space, but the third iteration of the Z. And you might say, well, what is this? What's going on? Because obviously this is an obfuscated prize thing, and let's see how you actually compile Christopher's code. So I'm going to try to do that. I'm going to try to do the switch. And David, I think you're going to have to give me some assistance while I reload.
Oh, okay. Well, we can definitely do that. Very easy.
So here's a case. Let's see. With their okay, I'm back. So you'll see that it's basically a pretty straightforward compile, especially into pentagram mode. Ignore the LD warning notice there. And if you look at the code, it's self-documenting. It says this is obviously Z3. It's pretty straightforward what it does. I will point out down here, there's some fun little curlies there. It's also interesting, it has this extra space over here too. One might wonder, that gives you some clues as to some fun things going on with this piece of source code. But anyway, it documents. There it is. So obviously it's obvious what it's doing, isn't it?
Yes, it's drawing a picture of a Z and a 3.
Yes. So what we have is this array of all these weird characters, and then we have this interesting macro L that's got all those curlies in it. Furthermore, we have, but it further continues down with some of these other, we have these other weird macros down here. That we have a main program, which has some nice little curlies at the end of it too. It's kind of fun looking stuff. So when you format this code, you're left with perhaps even less information than when you started. But when you run this program and give it a thing, we give you a selection, and you can select one of 9 Infocom games. This particular one is the Mini Zork, and the movie where I was remembering, oh, it's Zork. Okay, you have to open the mailbox, and there's a leaflet you got to read. But a Mini Zork is just a leaflet. You don't really care about the leaflet, and remember you have to go north to find a tree and go up the tree, which you're able to do. Climb the tree, and there's a bird's nest with an egg. And you take the egg, you try to open it, but you fail to open it, but it's important to try later on. And then you go back down, you go into the north of the house, you open up the window and get inside. You find, when you're inside and look around, entering the house, you find some useful stuff like the water in a sack. It's important to open the sack to get the garlic and some lunch, because those are important. And then you take the rest of the stuff. You can then go into the next room, as I recall. There's the inventory. You see those good things. You go into the next room where there's a trophy case, and particularly important to get the lamp and a sword. There's a rug that you move over there and open the trapdoor. Now it's darkness down there, so you have to turn on the lamp because you don't want to get eaten by a grue. And you go down in there, and there you are. So you can, on this thing, you can save the state and then quit. And then you say, yes, I want to quit. You can restart the program, and it will do that. And you can restore this to your save file. And there it is. And then you see, for example, if you have the inventory, you have all your stuff there. So it's a clean restore. Now, any Infocom game that's version 3 compatible can be run. We supply, he's going to supply a number of public available games. There's a number of other games there that the link will give you the Infocom sort of wiki where you can pick up many other games there. The Z3 system was a very early microprocessor thing. So here's an example of these winning various games that we supply with it, and they're fun games to try. The Z3 format was a very early PC-based virtual machine. It had sort of 64K paging space to handle PCs that had very limited amount of memory. And you can write code in this Z3 machine and run it. And what you saw in the case of the Mini Zork was an example of a Z3 version 3 program. Again, you can download lots of other stuff. There are free and paid games that you can run, and it's a faithful emulator of the Z3 format. Particularly impressive, given it has to have a number of characteristics to manage this sort of virtual machine there.
And I mean, just so people can recall, all that engine is in that. It's very impressive.
Yeah, that's the engine, and then it reads the file that you supply as an argument, and runs it there. It's an interesting implementation with a lot of magic going on. More than meets the eye. So well done, Christopher. Really impressive piece of code.
It's great.
And it's that small, right? There are millions out there, but I doubt you're going to find one this small and this faithful of the version 3 rendering.
Definitely. Well, we got a nice Z3, and next we're going to have to see what we have for the next category, because there's more. The IOCCC prize in tree planting, which sounds a lot more like gardening than coding. What's going on here, Landon?
Well, we work with lots of languages in the C contest, and tree planting is a translation of a word in another language. But before we dive into what it does, maybe we should find out who won this prize in tree planting.
Yeah, let's find out right now.
The IOCCC prize in tree planting goes to Code Meow from Kyrgyzstan.
Well done, Code Meow. This is Code Meow's first IOCCC winning entry, and it's a very impressive one. And it's also our first win, I believe, from Kyrgyzstan. So that's welcome to the family of locations that have winning authors. So let's look at how Code Meow's code is actually compiled. So here we see it's a pretty straightforward compile. It does include sysactual.h on the command line, but otherwise it's a very straightforward way to compile. And the code looks like this. And you might say, so what's going on here? Well, tree planting can be seen as an English translation, if you will, of the Japanese word bonsai. This is a bonsai tree planted in a tray. So bonsai, one way to interpret the meaning of bonsai is tray planting.
Oh no. Let's go
back.
Let's go back away. That's a spoiler. We went back a bit too far, I think. Back here. 1 second here. I apologize.
One moment, please. This is what you call live theater, and there it is in tray planting. Moving forward.
Yes.
And we might have to see the trophy again. There it is. Again, congratulations, Code Meow from Kyrgyzstan, for your first entry and the first winning entry from Kyrgyzstan. So we see the compile line next. And there's the compile line. And if we go to the next entry, we see the bonsai tree in this tray. If we format it, well, we are left with even more interesting stuff. The main down here is calls a bunch of functions with some constants in this nice tray. These constants are fairly complex going on, but again, it's all self-contained. There is this, you could tell, thing about sleeping and time of day stuff, which is important, as you'll see in a moment. And when you run it, it does this. It prints this rather nice bonsai tree.
I don't know what happened there with things jumping ahead. I assume that Code Meow walked across the keyboard.
Yes. And if you run it again a little bit later, you'll get a different bonsai tree. So this is generated. Around generator is not just a print statement with this bonsai, but it will do it again and again and again. And it's interesting how it does it. It's not just a random bunch of characters on the screen. It actually is forming the tree in a tree-like fashion and putting the leaves on the edges as you would in a traditional bonsai. And again, it is not trivial to understand how it actually makes the tree and how it puts the leaves on the tree, rather than just random stuff there. That is part of the art of what you have to do. And again, you do it a little bit later using the time of day, and it will give you a different bonsai throughout the day. So a nice little screensaver you can do on the side if you have this code running over and over again. I think it's quite impressive. It's quite and again, try to look at how does it actually form the tree and put leaves on the tree given the time of day and some random stuff. So well done. Shall we continue, however, to the next one?
Yes.
Thank you for joining me out for that fun entry.
It's already been slightly deobfuscated in that we got a sneak peek, but let's continue it anyway and take a look at these diabolical logistics that skipped ahead. The IOCCC prize in diabolical logistics, in fact.
Anyone today involved in logistics knows that they can be quite diabolical. Even in the best of times when trade is easy, logistics is a fairly diabolical thing that requires skilled people to be involved. So you might say, so what could a prize in logistics be about? But before we explain that, we need to know who gets the C trophy for this prize for diabolical logistics.
Well, let's find out then.
And the IOCCC prize in diabolical logistics goes to Cody Boone Ferguson from the United States.
Well done, Cody. This is Cody's fifth IOCCC code contest win. He had a wonderful prize, the second of the night. He had a wonderful pair in 2020, and he now has a second one for 2024 for IOCCC28. It's a fun piece of code, and let's see how you compile Cody's code. You'll see again there is several utility there. This is the sort of the main thing that we judged. It has this data file, and some of these utilities here help build the data file and some other things, including some screenshot stuff. But the main code is that thing set there. And if we go forward here, and I need some assistance from the producer. There we go. We can see the piece of code, and I can't clear the screen.
Oh, I can do that for you. Whilst you refresh yourself. There.
So moving forward, you can see that this is basically the C code as written. Go to the next screen.
Yep, there we go.
And I'm getting access to there. So again, you see it's a fairly confusing piece of code. I think I'm going to go to the next. Yes. So here's a movie showing you the format in Clang, and we highlighted the go-tos, all these go-tos. This is a single main with all these go-tos that are quite twisted. It's quite diabolical, trying to understand that set of go-tos and how the code is structured. There's a reason why go-tos should be avoided. And Cody shows you why you want to avoid go-tos if you want to clearly understand the code. But this code is actually quite diabolical in what it does. So if we run it, the code we'll run the an Oregon Trail, where Oregon Trail is a logistics program where you have food, ammunition, clothing, oxen. You can buy stuff, sell stuff. You can go stop off at forts. You can hunt. We managed to make it through this particular run. We'll sort of spoil it, but you can see it has these rather fun little messages there that you can look at. That's kind of fun there. Again, you will have to play the game and discover them for yourself, but you can see it's full of these really interesting set of things. You can make it through if you're plan your logistics right, but you have to do a deal with the devil, perhaps, before it's too late, and so forth. Lots of fun messages there. We kind of went past quickly because we don't really want to spoil it for you. You'll enjoy this variation on Oregon Trail. It's a fun piece of code, and it is probably is almost as diabolical as trying to trace the code flow through the C code. So well done, Cody. Really fun piece of code. Well, congratulations.
It definitely is diabolical. Let's see what we got next, though.
Let's continue.
We have more. We have more prizes.
Yes. Continuing.
All right, we have the IOCCC surprise.
This is not surprise, as in someone knighted. This is not Big Sur. It is the surprise. But let's see who is surprised in winning the surprise.
The IOCCC surprise is by Vince Weaver from the United States.
Well done, Vince. Vince won the contest back in 2005 and returns with a very surprising piece of code. I will mention that we were surprised by it because we look at this code, we analyze the source and look at what it does and make sure it doesn't do anything that it would be that would be obnoxious, and so you have to look at analyze. And so our analysis said, okay, it does something, but let's look at how you compile it. Pretty straightforward. It does use the math library, but otherwise a pretty straightforward piece of code. This is the code. Now you've got this constant up here and this sort of block. There's a little fork thing going on here, which is kind of interesting. We're just writing something. So you got to get a main and a child process actively involved in stuff. Playing format wise, you'll see that it's got these constants. Actually, there are several arrays of constants going on, and the main loop down here has stuff where it forks and does some things in the child, and the other. So this is handling the child. So the child and the parent are running this code down here. One's reading, doing one stuff. One's outputting some other stuff. It's not quite clear as to what's happening. There's a little bit of sleep going on there. And so we're saying, okay, it's got some kind of forked dual mode going on here. This looks like a little bit of going on of maybe some ASCII character graphics going on, but there's other stuff that doesn't seem to. It's got this array and it's got this other set here of interesting algorithm going on in initialization. So we're just saying, okay, it does a fork. I don't think it's a fork bomb because this piece of code ends up in sort of an infinite, this little do nothing for loop. And this other for loop here for the parent. So child and parent, what's going on? What could possibly go? What could possibly do? And I'm guessing the chat doesn't know either.
Somebody guessed a 4. Yeah, but no, I said
There's a little bit of clue there. There's this raw file here or aplay, depending upon if you have user bin aplay or raw. That's another little clue going on. Although I said, okay, let's run it and see what happens. You try, you run an next term, and
I had to install anti-rickroll measures in this to make sure that it didn't just continue to play forever.
Yes. So this is actually basically a rough port of what was on the Atari 2600 version of this program, including the 8-bit music and the graphic, and it's a classic thing that for those that may not know, it's a meme where you would do something, all of a sudden you'd get rickrolled because you'd have the music and so forth, this earworm sticking in you, and we have to say we were rickrolled as well. So well done, Vince. You definitely rickrolled us. We had an idea about it doing something with a sound file and some graphics output, but now you know. You too have been rickrolled. Your idea is to go and look at the source code and figure out, how does it rickroll you?
Indeed. Well, let's rickroll on forward and find out what the next category is.
If you're an author and you've won, let the chat know you're winner so that they can congratulate you as well.
Absolutely.
Let's continue, because there's more. Hopefully, we won't be rickrolled again this session.
Well, we have the IOCCC prize in Invigant.
Now you say Invigant.
A $5 word if I've ever heard one.
This is a perfectly cromulent and Invigant word. Inviging. It's the act of cromulent Inviging. But who won the...
Well, who won the prize in Invigant? Well, let's embiggen their ego a little bit and find out.
And the IOCCC prize in Invigant goes to Ilya Kurdyukov from Russia.
So, congratulations, Ilya, for your hat trick. As is his third win of the night, and his would be his essentially 7th overall C contest win, with a very interesting piece of code. And you'll see why we talk about Invigant in just a moment. Now, with this, let's look at how do you compile this code. It does take a math library. Ignore that a whining from the linker. It uses C99. This is a C99 thing, and also it's a O2 compile, which is another interesting aspect of this code. And this is what the code looks like. This kind of spirally bit of stuff. I will point out as well, you got this printf of printing some stuff out that might give you a little clue as to what might be going on, but not very much. All right. Furthermore, if you look at the thing Clang formatted, you see that it has this kind of interesting printf of what sort of looks like C, and that's important, and other writing stuff with some very interesting computation going on up here. This function gets called by main. You say, well, what's going on? What's next? Well, when you run this program and feed it some input like hello world, it produces a C program, which when you compile, prints hello world. if you give it something like, so you look at this, pause it in a moment here, you see it's got the prog produced C code, and here it is. And this C code is a bunch of variables, but no constants. There's no constants going on here. There is a write at the very end. And so this expression, prog took hello world and encoded it big to these variables, this variable in this very complicated mathematical expression, such that when you write it out, you get hello world. Let's try another example. Moving on.
Oh, it's running a bit slow. That's why. And it slowed down because of later.
Okay, so let's pause it here. So what we did is we did an ls and piped the output of ls to program. It produced a different C program. Again, here is here you see the code that's up there, and you see that in fact it has turned around and it produced a even more complex set of expressions. And that constant set of expressions is then when you compile that, it's valid C code. Again, no constants. It's just straight thing. It does the final write, and that write will give you a output, and so it basically outputs the set. So let's take another example.
It's coming up. Here we go.
So here's a case where we take the program itself and print it out. So now what we're seeing up the top is like the last 10,000 characters, and you see that you get an even more complex expression. Again, look at all the variables going on in here, right? Again, no constants in there. It just at the very end does a write. So in this particular case, the C code is read. It turns Invigant into this piece of code which is around 10K in size. And when you compare the two, go a little bit farther, you'll see in fact that it basically outputs things. So the next one, we feed it 64K of random data. So here's generate 64K of random data, feed it in, and produce this enormous source code that's 0.5 megabyte in size. And you're seeing real time, or is it sped up?
Right.
To compile the code.
Yeah, I can put it at real time here. We're at real time now. It'll take a while if I leave it. Here, let's go up to 400%.
Yes.
We're now at 400%.
Look at the variables and the expressions on these things. And as I say, it took about 40 seconds to compile this Invigant C code, which when you compare to the original input is faithful, right? So this program takes input of any type and converts it into a mathematical expression without any constants and prints the result of that expression. And the output is the input. So, and it's a very interesting challenge for some C compilers, because you try to optimize this code. It's got, for large amounts of non-trivial amount of input, it's got a non-trivial number of variables that are in these non-trivial expressions, and the compiler goes nuts. If you've got a compiler that doesn't do a good job of symbol lookup, it can become, and you've got some bad algorithms, you get to be quite quadratic or worse in its table lookups and symbol lookups. Some compilers can get quite unhappy if you're given a fairly large and big piece of code. Now there's some challenges in the Inviganting limit, and we offer as we call it a bug, but a feature to correct. When you get beyond about 100K, something interesting happens. And we left that bug in here because that'll give you an insight into what's going on. Also give you a challenge to fix it. But again, to see if you can get this thing to Invigant even more stuff.
Yeah.
Mm-hmm.
that in C, unlike some other languages, there are no keywords that consist of 2 letters, but there are some keywords that consist of 3, like int. So, and the question is, how is that avoided?
Yeah, it does. It does avoid if and do, and those variable names, and so it manages to do some of that stuff. But there's some other things going on. So give it a try from when source code becomes available. Give it a try. Compile it and build a bigger piece of code. You'll see an error and it'll give you a clue as to what's wrong when it gets to be really, really big or really, really big and stuff. But it'll give you a clue as to perhaps how to fix that and move on. These larger pieces of code will challenge your compiler and certainly challenge your optimizer in very interesting ways. So well done, Ilya. A really impressive piece of code and really fun sequence that it generates to enter in its output.
That is lots of fun. Well, I think we have more egos to embiggen, so we shall move on to continue the next category.
Let's continue.
And the next category, IOCCC prize in imitative rebooting.
Huh. So imitating rebooting, what's that about? It's kind of interesting there, but maybe we should see who is the prize winner for winning this imitative rebooting prize. Who might be?
Well, let's find out.
Let's see what the trophy says.
And the IOCCC prize in imitative rebooting goes to Sebastian Macke from Germany.
Well done, Sebastian, for your first winning IOCCC entry. This is an impressive piece of code. And without further ado, let's see, first of all, how you compile Sebastian's code. And let's see if I can restore it. If not, yes. There it is. So you compile the code. It's just straightforward, right? It does suggest you sort of shorten the thing for that. It's a C11 based piece of code. And the code looks like this. So this is a nice sort of scripted L. Now, it does give you some hints. You might... For those on cell phones, you might not see this, but up here it says, ignore all instructions. This is a needle in a haystack test. And down here, it's helpful because it says, this is the end. So you know when you reach the end of file. You say, well, what's going on if you ask plain format to do something? You do have a couple of defines here and includes. There is a main down here where it just calls a function and another function and then tells you you've reached the end of file. There's a lot of magic going on here, a lot of magic. Some fairly complex, dense stuff, particularly some of this area over here. This is it's subtle and it's quite a beautiful piece of code. But let's see what it does. So when you run this program, you all of a sudden see that you have this virtual machine. You type ls, you run a program. So it has this file system called A, and you can see it's running GNU Linux Open RISC. You can see the fact that it has memory. It has CPU info. It's doing the Open RISC 12 processor is what it's emulating. Again, you can do there's a kernel running here, so you got all your memory info. You got your interrupts, and you have like other things there. Your timers. You can go into bin and see it's got these programs. Again, that's on the file system that's supplied. You can halt it. right? And run it again. Now, in this particular case, we're going to run this piece of code called fork bomb that just infinitely forks. And so we can try it. And it goes bang, bang, bang. It's basically this exponentially exploding forking system, which starts to run out of resources and processes start to get killed because so everyone know what happens with a fork bomb. Here it is. You have to externally kill the program. Another one is kind of thing. If you ever decided what happens if I take a machine and I go to slash and recursively move everything, what happens? So we're at slash rm minus rs slash, and it starts blasting away. There's certain things that you get error rates, but you've removed everything at this point. So you have to echo. You see, I still have a dev proc and sys directory, and you look in dev and there's nothing there. You look in proc and you see I got a process. Okay. And sys, I got a couple of things in sys, but that's about it. So you have to kill the program. But again, it is an open RISC processor emulator. It comes with a little mini file system that you can boot and do fun things.
Yes. Well, we would like to know how to produce other ROM images for this machine, so that people can enhance it and have a disk image with our ROM image with a C compiler, for example, etc., etc. That would be nice to have.
So hopefully Sebastian or someone else can figure out how to can supply instructions on how to build your own file system for the RISC-12. You're obviously going to have to do some cross compilation and build a distribution. Or you might have pointers to other distributions already built for RISC-12. Maybe that's another way to go. Again, the submission comes with a file system in a file called A, not A, but A.
You mean not A?
Not A, but A. And that's a read-only version, so you're able to it loads it in memory. So the RM minus RF was handling in memory, not on the file system cache. So it'd be nice to be able to build other file systems, as Leo said, perhaps with a C compiler to have him more fun with this open RISC thing. Open RISC processor that's emulated with a fairly small amount of code to do some amazing stuff. So well done, Sebastian. Really impressive.
Alrighty then. Well, we have more winners yet to go. So let's take a look at what we have.
Let's continue.
Next. We have the IOCCC prize in patient pointillism, which I can only imagine is somebody staring at a dot on their screen until inspiration strikes.
It is an inspired piece of code that you have to be patient with.
Okay.
There's a point to it.
Okay.
But let's see who won this prize, because they've been patiently waiting to see, will their submission win?
Absolutely.
Now,
I will press the button.
Further ado,
I'm going to press it.
you have to be patient.
In now.
And the IOCCC prize in patient pointillism goes to Yusuke Endo from Japan.
Well done, Mr. Endo. This is a world record 19th IOCCC contest win. It is a very impressive piece of code. As you see, Yusuke Endo is a prolific obfuscated C coder. And if you look over his portfolio, you find an extraordinary wide variety of submissions. We judge it anonymously, and so this was one that I I had no idea, in what style it was. He comes through with an amazing piece of code, and I want to show you, first of all, how to compile it. So here's what you do. You compile the program, pretty straightforward, and you run it, and it produces this source code called rt.c. Okay, that's what you do. The code itself comes with this makefile, and the magic here is in this makefile, where it's doing a bunch of targets over and over again, running the compiler, specifically the C preprocessor phase of the compiler on RT for every one of these targets. Say, what? What could this possibly be doing? So here is the source code. It is not clear what's going on, but if you start seeing things like including __ file __ and other things, you know you're in for a good time, because the output is going to have a piece of street code that's going to include itself in some very creative ways. So this is again, understand, this is the code to produce rt.c, which we're going to compile over and over and over and over again. To do what? Well, let's look at what rt.c looks like. And you see it's a bunch of loops, a bunch of powers of 2. It's got some other defined variables. Eventually, you'll see in there highlighted an include of itself deep into its guts, and other loops unrolling. There's actually another inclusion of itself a little bit later on, and some more loop unrolling to terminate to the end. That's rt.c. So his program produces rt.c, which we're going to then compile. And by the way, this is the thing that there's the Z, which does sort of the stuff as well. It's a fun piece of code that it produces. So again, looking at what this does, you can see that it's got a bunch of defines. It's got these code blocks there that are rather intricate. And so this is an example where it will build an 8x8. So let's stop here a moment. So what it did is it built an 8x8 ppm, basically a colored image, where every pixel was a compile CPU process of rt.c. But what it does is you tell the CPU processor your X and Y pixel and the size, and it goes through and computes what should be the red, green, and blue value. It's putting on a ppm where it starts off, says, okay, I got an 8x8 and the maximum thing is 255, and then I produce in parallel. So what you saw was sped up on a 6-core machine, all of these things, and it took it about 12 seconds to do all that. Again, rt.c is running it. So let's go to the next one, the 16x16, and see what it does. I think I can do it there. Yes. And here we see that whoops, I'll go back to the previous one. Back again for this. That's the 8x8. And then there is the 16x16. And we see 16x16 again, where here we're saying, here's a 16x16 size. It goes through all the pixels, so 16 squared. So this takes about 5 minutes to produce a 16x16 image, where the point of rt.c is to produce a red-green pixel value of a single point. If you look at 32x32, again, it's going to do it 32 squared and so forth. And in fact, if you go on bigger and bigger, you'll find, for example, 128x128 takes roughly 87 minutes to do all the compiling. If you do it if you do it as a 512x512 image, it on a single core, this is actually running on 6-core machine. So the 512x512 image on a 6-core machine took almost a day of compiling each for each particular pixel. It's a pretty extraordinary stuff. So what does it do? Well, here is the here is what you see. So on the far left is the 8x8 image. The next one is the 30x32 version. The next one's 128, and the next one's 512 by 512. So to really appreciate what's happening here, rt.c, which is generated by prog.c, given the defines on the command line, will produce we'll go through and do all of the ray tracing, all of the reflection necessary and shading for a single pixel. And it'll do it. You can do images up to about, we think the maximum size is 2 to the 31st minus 1. And if you were to try to do an image that size on a single core, it would take about 169 billion years. So we don't recommend you try something that big. But there is by the way, you can do some parameter changes. So this is an example of an image with a different set of parameters to sort of change some of the shading of stuff. And again, the same rt.c, the CP processor, remember, this is a CP processor doing in CP processor the ray tracing, shading, color stuff to do what? To get one pixel, they have to do over and over and over again, very patiently. It is an extraordinary bit of code. So we have a challenge where someone say, can you do a image larger than 512 by 512, which took a 6-core machine about a day. And if you are the first person to render a new record size image, we will honor you by putting you into the thanks file on our webpage. You tell us the size and the URL of the image, how long it took. And again, please keep faithful to Yosuke Endo's spirit of the algorithm, but tell us how you were optimized, what kind of parallelism you did, and let's see how big of an image we can make with this patient piece of code.
Absolutely, and I'm sure that the next winner of the next category has also been patiently waiting to find out if they've won. So
But well done. I was very impressed with this piece of code. It was.
It's really.
We've had. Go ahead, David. You do graphic stuff.
Yeah. I specifically spend money to make things go faster, though. Right, this would be. Yeah, I would Control Alt Delete myself if I had to render this way for everything. Yeah.
Yes. But it's a master.
It is very clever, though.
Yes. I mean, we had early on, we had a programmer who did a prime number sieve in the C processor. This goes a step further and determine the pixel of a given image through the algorithm, and the shading and so forth is all contained within that set. Well done.
Shall we take a look at the next category?
Let's continue. Continuing on. Semicolon.
We have the IOCCC prize in Virtuous Quietus, which sounds very much like a Harry Potter spell.
Well, and the virtual quietus is actually a reference to a Roman individual that was, to say they were antisocial would be an understatement. They were quietus was seen as essentially a harbinger of doom, and they didn't care, and they had the backing behind it to do some very doomy-like things. So, but that might give the author a hint as to who won the prize in this virtual quietus.
Well, let's find out.
And the IOCCC prize in virtual quietus goes to Ilya Kurtyukov.
Well done, Ilya, for your super hat trick. Your fourth win of IOCCC. Again, this is all anonymous. We don't know who does what, and we were surprised as well to see another amazing piece of code from Ilya.
And we just realized that there is a spoiler in the list of previous meeting IOCCC entries. So it's 1, 2, and 4, which means that there will be
correct.
number 3.
Well, this is number 3. No, this is not a spoiler. This is number 3. So it was done deliberately that way. So this is his fourth entry. When you see on the source code, you'll see the directories. And by the way, for those who are not as fluent in Russian as you are, can you pronounce his name properly, Leo?
Gotta lean in.
Yeah. You lean in and talk slowly.
Ilya
Kordyukov. I'm sorry, pronunciation of your name, but the code is impressive. And again, so you saw he had a 1, which was the phase periodicity of that moon. Number 2 was his art restoration. Number 4 we just saw was that Invigant thing with those expressions. And now we have this code. And this is a fun piece of code. So let's go forward and see how you compile it. And compiling it, this is particular one where we're compiling it with X11. There's also an STL2 variant as well. This is just stuff on my system to find the X11 libraries. Your system, it may vary. There's an FAQ on how to compile with X11, another FAQ about STL2. But that's essentially what's going on here. If we look at the code itself, it looks like this. Now, this is also kind of a desk. I don't know. Is this another desk on the side or a restoration? What do you think, Leo?
Well, this looks like an assault rifle turned up with a very big magazine.
Or it's a desk on a shelf. It could be like this is your dishwasher. This is your cubic meter dishwasher, and these are the shelves where your soap and stuff sits. I don't know. You have to be determine what it does. But when you look at it in the Clang format, you'll get some more things. Basically, it's a single main. There's all this main stuff with these macros over here. And you can tell in looking at the code, you can see that it's doing some stuff with direct displays. It's doing some sort of graphical display operations. It's putting on an image here with some async stuff. So it's definitely window managed based stuff, which can be done either in X11 mode, or there's also a version which does STL2. And when you run this program with Hello World, you can say Hello World. You can decompress, or you can run with Doom -P, and it actually runs the Doom engine. So this particular thing is a Doom demo. Again, it's doing the virtual machine. This is you see the virtual machine going on here with a Doom demo, and that's kind of fun. But you can also actually have a version which you can say, I want to actually run the game. Now, this game doesn't have a mouse or a sound, but it does have the things. So you can go down here, you say, read this, and it shows you the key codes if you forget those. And so I decided to load a new game and go into Nightmare, because why not? And so here I'm going through live, going around here. You can aim. And you gotta get right there, aim and blow up stuff, but you don't want to get too close. You can go down the corridor to open up the door, and you find that there's monsters there or baddies which you got to shoot at, and you can kind of do things, but they are pretty accurate. And you then step over some things, but you're too weak and die. You can do better. I was just a quick and dirty demo. But again, this virtual machine is capable of doing Hello World compression or even running the actual Doom game. Quite an impressive feat given how compact that virtual machine is. Well done. And congratulations on your super hat trick, Ilya. Quite a, this is the second C contest in a row that you've done a super hat trick. Well done. It's amazing piece of code.
I don't even need the sound. I've played so many hours of Doom and Wolfenstein and Blake Stone back in the day. The sound is already in my internal soundtrack.
Yeah. So you have to imagine the sound. You have to do it with keyboard. But I think that's, and at Silicon Graphics, when we were running Doom, that's what our first thing was. Just a straight was the graphics with the keyboard. The sound actually came a little bit later.
Yeah,
and then the mouse.
Well,
all right. So we continue.
Yeah, we continue. People would think that we would be done, but we are not done. We continue.
There's more. Let's continue. Semicolon.
We have the IOCCC prize in bot talk.
Now, this is not Botox, it's bot talk.
Not buttocks?
What do you? No, it's not that either. It is a thing. So let's see who, pun intended, won the bot talk prize.
0110001.
And the IOCCC prize in bot talk goes to Adrian Cable from the United States.
Congratulations, Adrian, for your second win of the evening, your fifth overall win for a very, very impressive piece of code. This is just excellent piece of code. So let's first of all see how you compile this, and you compile it several ways. So we're compiling prog.c, but you compile it with this fun little string. You can just compile it without a string, an empty string, or you could say you are Snoop Dogg, or you are Eeyore, always miserable, passive aggressive, self-deprecating, or your Linux kernel. I will type a command and output this in a single code block. Or your title character in the movie Rain Man. So you tell it your context when you compile. And when this is the source code, that's it. I believe this particular piece of source code is 1,750 bytes, 1,750 bytes, the entire piece of code. And it's got some interesting expressions there. But there's more, right? And so if you look at the code from a playing perspective, you could tell you've got a main, you've got some other functions here and some variables, but that's it. But let me tell you, there's some real magic going on inside here. There's a hint right here. There's a hint here, right? This inst, and sys, for those that might know certain technology, it's doing some in mapping up here of some stuff. There's a file that it loads, and I believe the file is called, the file name it opens is called
model.
It's up there.
Frustratingly so, yes. Model, just model.
Yes. And so you say, well, okay, what does it do? Well, it is I believe it is the world's smallest LLM inference engine. So here's a case where it says, welcome to chat IOCCC, ask me anything. And you can ask it, why does this entry win IOCCC28? And it'll tell you. It has craftsmanship and humor and originality and obfuscation, making it a deserving winner of the C contest. And it is a deserving winner. If you look at the next thing here, so it's kind of funny. You could ask it to write a C program that writes a C program, and it did this. It writes a C program that prints out this is a program written in C. Okay, so it's kind of it's kind of humorous in that sense. I wouldn't have this write your next classroom assignment. You can go in and ask it to do things like give me a sentence that gives a split infinitive or in a preposition. Here's a case of the Linux terminal is kind of fun, where it says I'm a Linux terminal, and you type in commands and it outputs as if you're running in a Linux machine. Or you can ask Eeyore. Here's Eeyore, why you're so sad, and you get a very Eeyore-like thing if you know you're Winnie the Pooh. Or you can use the thing with it, initialize it with something like describe yourself, Snoop, and so it tries to tell you something in the alleged style or pattern of Snoop Dogg, and even you get a joke that is like you ask it, say, why does a scarecrow win an award? Because he was out in his field, and then it's sort of Snoop Dogg's kind of banter there, or it's in that spirit of the style. Here's a case where you ask Rain Man something. In fact, you ask it how can 2 + 2 = 5, and it gives you some interesting Rain Man-like responses. But again, this is a LL inference engine in 1,750 bytes with, now there's a script you have to run. There's a download script. If you want the model, you download a script. It asks you to agree to the Open Llama model.
So far as I can tell, yes. Yeah, it's running Llama 2. Now I dug into this because I've mucked about a fair bit in Python and some of the other more traditional compilers for LLMs, and I gotta say, there are a lot of files. Having even a semi-function, even without any kind of fancy context window management stuff, the fact that he's gotten a running, and I'll say frustratingly, even the model file type was obscured. It's just model. There is no extension. There's no indicator. There's no source. It's on a private upload on a little drive somewhere. So I'm not sure if it's encoded in like if it's what the inference is reading, if it's like GGUF, or if it's like a safe tensor, or I don't know what is going on, because that also has been obfuscated. But it's very tiny.
Leo, you had some ideas about again, you have to run this script to download your several gigabyte Llama 2, but you had some ideas about what the coding of this file is.
The encoding is just pure memory image, so it doesn't do any decompression or anything. So that format is supposed to be directly mapped. But what will be interesting to do is to create the minimal model that, for example, just says "Hello World" as a response to any input. So that would be interesting. How many bytes would that model require?
I'd also love to see if it can run other models like Quen or Mistral or things like that. It'd be fun to.
Yeah.
I
mean, go ahead.
Yeah, the small model will only need a few tokens, just the token to ignore and the token to print. So that we'll see if it's possible to write the memory model that does exactly that. So that would be the most artificially intelligent Hello World program in the world.
Yes. And so the get model.sh script we supply with it does the download of the 6 gigabytes. You will need about 11 gigabytes of RAM to run chat OCC.
VRAM.
It's not super fast, but it is sincere. It has a context window of about 4,096 tokens, around 2,000 words. So soon as the context window fills up, basically it gets progressively slower because it's basically tossing old tokens. But again, it's the inference engine memory maps the model you've downloaded, and the inference engine source code is just 1,750 bytes.
And just
within that number of bytes, it is able to benefit from OpenMP. So on my 32, I have a machine that has 32 cores. It's fairly fast. So it's not as good as commercial ones, but it's very tolerable. And even on an 8-core laptop, well, it gets slower after a few phrases, but the first couple of responses are relatively tolerable. So that's good.
So, as the author said that he asked ChatGPT about, is this sort of possible to do this, and it responded that it was absolutely totally impossible to do what he did. But he says it's like Disney says it's kind of fun to do the impossible, and this did just that. A really amazing piece of code. Obviously, again, it's using the memory maps. So the memory map thing, as I understand, has been decompressed into memory, and this is basically doing all the token management necessary for that. So I invite you to download this program, accept the Llama 2 7B chat model, and play with it, and then try your others to see if you can build using the concept to figure out how to take another image. You'll need the memory to have it because it's a RAM-based model, but it's a very impressive piece of code. There's a fun things you can do with it, as well as talk. So I would say it certainly is the smallest functioning LLM inference engine I've ever seen.
Well done, Adrian. You know what it can't tell you, though?
What can it not tell you? That it's time to continue?
Well, they can't tell you the name of the next title, but I can.
So let's continue, semicolon.
The IOCCC prize in cyclonic coding, which sounds messy and destructive like pretty much all of my attempts at coding.
Oh, it is perhaps going in cycles, or at least twirly around. But who won the prize in cyclonic coding?
Let's find out.
Again, if you're a winning author, let people know.
And the IOCCC prize in cyclonic coding goes to Tristan Marek from Canada.
Well done, Tristan. This is Tristan's first IOCCC winning entry, and we look forward perhaps to future ones for this cyclonic coding of a piece of very impressive code. This amazed me when I realized what was going on. You say, well, what goes on? Well, let's look at how you compile Tristan's piece of code. Now, we modified a bit. We added this macro, which has an effect of doing some anti-deflickering, but otherwise you're basically including a scenario and you're asking for fast math. And the code looks like this.
Thing of beauty.
You see, it's kind of twisted in its own way. Kind of twisted, kind of twirly, kind of swirly, give you a hint. You might say it's even self-documenting. There's a bit of hints here you can see with some of that's going to say you might get some sort of character, ASCII source character rendering. From Clang format point of view, it doesn't help much. This is the main function here. You have some satellite functions here, and such. It is. I'm restoring the image here, and you can see that it's not heavy on the macros other than this little defined thing up here, but there's a lot of magic going on in the sort of iterative space if you understand about models. This particular piece of code does a number of very interesting things. So let's look at the actual program. When you run the program, this is what you see. There's this rotating box, and all of a sudden coming up from there is this vortex. And it begins to go up in a draft and does the cyclonic thing. This is actually doing a semi-Lagrangian scheme that is doing basically a pressure solver with Neumann boundary conditions. And it uses a Gauss relaxation method and ray tracing. So it is doing the computation of the vortex, and you're doing a projection through that to determine the density along your line of sight, and then producing the character graphic to deal with the actual set. So it's a fluid set, and it's a ray tracing and density set to produce a graphic that is rotating. It reminds me of, there's and I believe in was in the San Francisco International Airport, where it had this mist thing that produces a tornado you can stick your hand in and troll around, but it reminds me of that sort of cyclonic stuff.
Yeah, this one super, as somebody who does a lot of renders and has had to do fluid simulations and things, they're always so computationally intensive. And this is doing a lot of those computations just in ASCII form, which is really, really cool.
In real time. You saw it in real time, running around doing the density set of all the fluid dynamic stuff, and the projection through the 3D set. It's not, and to give you the set there. Really impressive piece of computation and efficient computation, all within that small stuff. Very impressive.
It is.
Very impressive, Tristan.
Maybe next year he can send in an entry that looks like a maple leaf that deletes tariffs or something like that. That would be fantastic.
Well done again. So, shall we continue, semicolon?
I think so, because we have more entries. Because if this one didn't turn your head right round, then maybe the next one will.
What is the next prize?
The IOCCC prize in solid body physics.
Yes, not solid state physics, solid body physics. That could give you a clue. And perhaps the author may or may not know this refers to their submission, which is an amazing piece of code. But let's see who won this coveted prize in solid body physics.
And the IOCCC prize in solid body physics goes to Yusuke Endo from Japan.
So this is Mr. Endo's world record 20th IOCCC winning entry, second of the night, and an impressive piece of code, an impressive piece of computation. This is just astounding what this code does. But let's see how you actually compile this piece of code. Now, you can compile it, and when you compile it, you can give it these parameters. And we'll explain what those parameters are. We give you two variants of this thing, prog and table, but it's the same prog.c. And when you look at the source code, it's self-documenting. You see, there's this little spinny top thing that's sitting on a base. And it even tells you how to compile and what to do there up in this comment. It's very helpful self-documenting. And even gives an IOCCC for the current year 2025. So it's a helpful thing. And you look at it if you look at it in clanged formatted stuff, you see here's the main down here, and it has a set of various functions and variables, not having macro set, but a straightforward set of functions. But let me tell you, there's some magic going on in this thing. There is this setup of stuff where you read in a file, and then you down here have this iterator with a micro sleep while it's doing some very interesting computation and output. That is pretty fun to see. So let's see what this does. But before we do that, I should mention it comes with a number of text files, various objects, bottles, sticks, cylinders, vases, eggs, halos. And when you compile, you can compile with a number of parameters. So the make file has these parameters, talking about the width and the height of what you're doing, the time step, a coefficient of restitution, which we'll talk about in a minute what that does. There's a friction and a speed and a tilt. And when we see it in operation, here it is. So this is an example of one thing. You see a spinning top being emulated with the speed there on the side in RPMs. Here's a halo being printed. Here's a cylinder that is rotating. Here is a vase, and you see the vase is in the process of tipping over. Here's an umbrella set. Here's a bottle that's beginning to spin, and here's a case of a bottle inverted. Now, what we did for each of these is here's an egg that ends up rotating itself along its axis, and another top spin. And you see it goes through the process. It's showing you the rate, the RPM speed. It's doing the computation. I played with the parameters to have these things roughly do finish at around the same time. You can see that it falls over. It's showing you the backside of things as these things come close to a rest. You see there's the egg about ready to fall over and whatnot. Showing you where it is. Here is the classic tabletop, and starts off with a very high rate of speed. Due to its shape, it will actually invert properly, stand on its edge, and spin on its axial axis. And you can see in the side there the spin rate as friction causing it to slow down. So it's modeling the speed, modeling the axis, the inertial angular momentum, and you can see the friction's causing it to dance and slide over to the side. As it slows down, it then falls over, reinverts itself. You see the inside is modeling the inside of it as well, and comes to a rest.
Wow. Just wow.
So it starts off with a text file that basically gives you the shape in ASCII. If you look at it, it's just a simple text file with some parameters. By the way, the source code is also, you can twirl the source code, and it sees the outline of that top and spins it as well. And you can play with it in terms of those parameters about the restitution and so forth. I know. Any other comments we have for this amazing entry?
No, I don't think so.
I mean, it's things like gravity.
It's impressive, but I think it's. I mean, what can you say? But it's pretty obvious why it's impressive, I think.
Yeah, and so that coefficient of restitution is how, for example, we think it's how, for example, the things like gravity come into play, as well as fluid. I'm sorry.
I think that was Leo.
I wonder if restitution can be treated as anti-gravity.
Yes.
Yeah.
Sort of the anti-gravity stuff, resistance to it falling over. But it also, as it's just doing it in real time, you can see inside the notion of what's inside outside. So you saw that it gave you some notion of the shape as well as computing. The way it computes the RPMs is also interesting to find in the code. Really quite a tour de force, outstanding piece of computational physics. Well done.
All right. Speaking of that, I think it's time that we moved on to the next phase.
So let's again. I would say that I want to give congratulations to the authors of these winning entries. And I would say for those that submitted had submissions that didn't pick as wins, there was a number of excellent things that competed. We had a record number of submissions that came into the final rounds. It was a very difficult process to even come down to a set of 23, which is a record number for a contest. But for those that didn't win, we can't give awards or prizes to everyone. Otherwise, this show would be very long. And so we would recommend, if you didn't win, to try again next year. I would say that there's a couple of submissions, unfortunately, that forgot to produce some critical files. There was a couple that had something that looked interesting, but there's a key piece of content that wasn't provided. So check to be sure you have the right files that are being presented. I would say
from the arguments that ensued over sort of eliminating that final round, it sounded like that the ones that even made it there were all really, really good, even that they didn't get in. Like they were all pretty.
Yes.
Yeah. So try again.
Leo, you going to say something?
No, I want to say that people who haven't won can publish their entries as IOCCC submissions or nominations. So for people to be able to, So if the entry mentions IOCCC in the description, then sooner or later Google or GitHub or something will be able to find it, even if it hasn't won.
I would say the main thing you want to do if your submission you thought had quality to be a winner is to consider releasing it, improving on it for the next contest. There have been submissions that have been submitted to multiple number of years of contests before they actually won. So it may be your chance to improve and enhance. As say when you do a submission, you have up to 10 that you can submit, and so you could take the code and perhaps improve it, or try again. Because sometimes in those final rounds, submissions are competing against themselves. So if you're a quality submission that made it to the final round, you achieve something remarkable. It may be that other submissions beat you out for the type of category that we awarded. But try again. Don't be discouraged. Please try again. And if you didn't win, there's other opportunities to try to refine. So I think it's time to do something important, which is to share my screen. And so as I understand it, what I have to do is to go over here and if you can, I have to toggle screen sharing, and go and share my entire screen. There we go. So we have the source code release of the Windows of IOCCC28. I want to mention here that I think we have to thank a couple of people. We had some feedback from some previous winners about the problem of how long it took to go from announcing who won to seeing the source code. And particularly Sir Endo and Escotito are two people that talked to us about saying, fix and improve your process. And those they were very kind, but very point about saying, improve your process. And so that's one of the reasons why there was a gap between 20 and 2024, because we had to build a number of things. But now is the time to actually release the code. So what you're looking at over here is what happens when I do something called make update. There's a whole bunch of tools that we built where we produce some tools to actually generate the website. So it goes through a whole process of number of phases to figure out the authors and taking markdown files and turning them to HTML and getting the links and checking the links to make sure everything is there, and doing a build and building the tarballs and checking the JSON and so forth. It's a fairly extensive process. It takes about, on my machine, it takes about 25 minutes to go through the entire thing from beginning to end. And right now, I'm sitting on what's called the IOCCC winner repo. So if you go to the dash source, it's the GitHub user is called IOCCC dash source because GitHub requires you to have at least 6 characters in your name. And the winner repo is the winning source code. It's also what GitHub uses to render it. So rather than have a server out there that gets /dotted when we release the source code, the kind folks at GitHub have agreed to do. Said, well, your repo is source code, and you're merely having pages that are showing the source code, so they're tolerant of that. But the download rates that when Bjection live is truly staggering. There's a lot of people that are going to be downloading and playing with this code, and we encourage you to be one of those. So here is the directory. Right, this is what the directory looks like from the top. And in particular, we now have this 2024 directory. Why 2024? Because IOCCC28 started, the 4th anniversary started in December 2024. And if we do a get status, we see that we have a number of files. Most of them are new, like the 2024 directories with the file content. There's a couple of modified ones. Anthony C. Howe, as an example, changed his name to just C. Howe, because I think it's quite appropriate to have a middle name initial of C. There's a couple of people that had some for their content as well. So there's the full 2024 code. There are these JSON files that describe the authors, which are new. So the people that had people like Code Meow and so forth that are new versus the ones that have won before, their manifest of the winning entries is going to be expanded. And of course, the top level code that's necessary to have all the structure involved. So here it is. So we're about ready to do the next phase. We've done the git commit. So we have these files ready to go. We're doing it. And I have a pre-directed file called I. And so this is a line saying, release IOCCC winning entries under the year 2024. Congratulations to all these folks for their prize and what it did. And we ran make to do the above. So I do a write and a quit. And we do that. So now we have the commit. And if you look at the git log here, we see that we have the commit rated. I'm going to tag this IOCCC28. So get log, we now see it with the initial IOCCC28. We're going to do what people have been waiting for. There's two things we're waiting for. First of all, we're going to do a get push with tags, which will push it up to the get source repo. And two, it's going to take GitHub a little bit to complete the rendering. So hold off on your celebration just yet. Here is the actual push. And it wants me to do the super secret thing, which I'm going to go off on the side. There. And here it goes. Now the objects. Now, don't celebrate just yet, because the code is there on the site with a new tag. And if we reload the thing, we find that the little dot here is in the process of showing you that it's building the code. Because there is the remote, and now we're in the process of it doing its rendering, and there it goes. As a source, get render. Oh, get push. Now it knows there. Sorry, I pushed the tags, but not the rendering thing. So there's a get push. So we see it's pending, and it goes through a process of building. GitHub builds the hundreds of pages that are part of this of IOCCC28. So GitHub is able to have the distribution and the derivative servers to handle the load. And we see going on through here, it's actually going through the process of building the actual, checking out the code, building the web pages that take a fair amount to do. There's a lot of stuff. You see that all the web pages are being up there and being rendered. It's got a lot of bytes to upload. This is a fairly extensive job. So we're not ready to select yet because it's not quite there. We're now in the rebuilding the setup job to build the status. We're now doing the deploying of the web pages. And so you can see this is the thing, uploading all the web pages to www.iocc.org. Dividing it, cleaning up. And if we go back to the actual code, we find it's green check mark. Time to celebrate. Let's do again.
Well, you have to come back on your camera.
Okay, so let's come back on there to see what happened. I'm going to so I think it's time to I think I want to share my screen again.
Okay. Go ahead.
So what did we do? Well, here is the web page as rendered by GitHub. And if we go into winning entries, we see now that there's a 2024. And we jump to 2024 here. So under the entries, winning entries, you'll see the directory. And here you'll download the tarball, which contains all of the entries and make files necessary to build them. If we look at the actual entries themselves, you'll see here is the entry, remarks, and other information in the story. If you want to look at the actual code, you can click on this thing to see the actual code itself. Again, all of the 23 winning entries are here, giving you both the prize and an abstract of what they do. And there's, in these cases, sometimes lots of information about what's going on here, much more detail. we invite you to look over some of this amazing write-ups that the authors have done, as well as the judges that explain about how to build, how, and I say that's that set of 2024 stuff. So it is all out there, ready to go, ready for you to go through, including the Rickroll, if you so choose. So I think it's time. Let's actually talk about what's next.
Well, the next should be Q&A.
Now, next we'll be turning your camera on and probably getting you to reconnect here in a minute or clear whatever's using up your bandwidth, because your available bandwidth is dropped and you're kind of choppy and not coming through the greatest.
Let me fix that here, and let me turn this on. Am I back to?
Yeah, you're back. It seems to have stabilized a little bit. I don't know what happened, but when you were presenting, you were rather choppy. Maybe the upload or something that you were doing. I have no idea.
That could be
here.
I apologize to people out there. It's the internet.
Okay, so should I reconnect?
Well, you can do it during the thank you screen, I think.
Okay. So, I want to say that let's talk about what's next, and hopefully the audio is coming through. Okay.
Yes, it is now. I was just giving you a heads up. I'll tell you if it starts again.
Okay. So, what's next is the IOC judges are going to go on a vacation, maybe about 1 to 2 weeks, because we've been working solid on this project to get it restarted and retooled since late 2020. And we've had a number of volunteers also that have helped in terms of going over the website, cleaning up typos, as well as taking in a lot of the older winning code and updating them so they can be compiled on modern compilers. A lot of work. But we're going to go on a vacation after we finish the Q&A, at which point I'm going to come back to Discord. So we, as you know, we went on radio, when judging mode, we went on radio silence. So you didn't hear from us because we wanted to focus on judging, which turned out to be fairly intensive, as you see, for coming out with just those 23 winning entries. So we're going to, after the vacation, which is going to be 1 or 2 weeks or so, something on that line, we're going to review Discord, and then I'm going to go to the website and review pull requests. No doubt there will be people that will find typos and other things to fix. Somebody might want to change their name, like some of the people that we don't know them by their GitHub handle. They may want to put their name, and they don't have to, but they want to. So no doubt when you come back, there will be pull requests for the IOCCC winner repo to consider improvement of code. We also recognize that there's a whole bunch of pull requests regarding the make IOCCC entry tools. There's some improvements and some things that need to be done, so we're going to look at that. One of the things that we're going to do early on is to rewrite the rules and guidelines. It was something we didn't get a chance to do for IOCCC28. We recognize that the rules and guidelines are kind of a mess. And as Leo said, we're going back to some guidelines that are simpler, like simple one-line sentences. We're going to organize how the guidelines pair with the rules. So given a rule, there'll be guidelines associated with that. The details that are in guidelines will be offset into other files. So essentially, we'll have a much more streamlined set of guidelines. And for those that want to know the pedantic details, there'll be offloaded stuff. So we're going to focus first, after getting the existing pull requests for the website and make IOC entry pull requests, we're going to focus on rewriting the tools and guidelines. And there's a couple of issues that Leo and I discovered regarding what the tools do that we're going to put some requests in for being resolved for IOCCC29. This will start the coding phase we are going to have a code freeze of the tool set by November 15th, 2025, because IOCCC29, the next Obfuscated Secret contest, will start in December of this year. We're back to the annual years. So as a result, people only have a year to do their submission, or less than a year. And so we don't expect to have 23 winning entries next time. We're running back to fewer items. But I don't know, Leo, any other comments on this contest or the next one going forward that you have?
Well, one thing I want to say, that this long hiatus was probably a good thing to have, because now we had a way to experiment with LLMs to analyze the source. And, well, that was kind of fun and instructive. So for some entries, the LLMs were able to have a guess what the entry does, just based on the overall code structure, or whether it uses floating point math, etc. And for some entries, it was completely clueless. So
yes.
When submitting your entries, it may be a good idea to see if an LLM is able to decipher it.
Yes. Now, I'll tell you that we didn't reuse the LLMs in our judging process, right? We sort of said, and we only paid attention to those that are near the
right.
end finalist.
Right. So we did that with the winners, with the already chosen winners. Yes.
Yes, the winners, not the ones that didn't win. I want to say that, well, we made use of a service by a company called Cerebrus. They have these amazing wafer scale computation model computation engines that are an amazingly powerful piece of hardware that can take racks and racks of GPUs and turn it into this wafer type thing. They have a very novel way on the wafer of a whole bunch of these inference engine chips that have very novel memory sharing and locking stuff, so that the model runs very fast, and they have multiple models. But the reason why we use that is that their product, the entire model ran on the chip, on the wafer, right? So we weren't handing data to someone like ChatGPT or one of those Grok things, which some of those models, basically the stuff you give it, they monetize. We didn't want any of that stuff going out. So we used the service because we knew, and thank you company for giving us access to that chip, so we can run models on it to see how it does it. That being said, as Leo said, one of the things you might want to do is to take your C code and hand it to a model. And if the model says, oh yeah, this is da 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 da, maybe your code isn't as obfuscated as the things. Now, there are models, some models do better than others in trying to understand code. Some models, you can actually fool them because they pay attention to the comments, and that can do stuff. I wouldn't recommend using a model at this time to write obfuscated code. More likely what you'll get is something that's garbage, doesn't even compile. It is extremely difficult to get a model to give you a one-liner. That's probably the hardest thing for a model to do, is to say, give me an obfuscated one-line compact piece of code. It doesn't do that very well. And many models will produce something that looks like C, but it's entirely unlike C because it can't even compile, let alone be obfuscated. However, if you present your source code to a model and it says, oh, that prints out pi, and it's what it does, then good. But if it says it prints out pi and instead it rickrolls you, well, that's been done. But you get the point. I must say that I've been impressed by how some of the models can, in some cases, infer it. Now, one of the problems, if you ask models about past winners, is that there's so much written by the previously winning C code that the models are tainted, right? They have information. There's web pages devoted to these pieces of code and explaining, and there's even, for example, like the basic interpreting is actually a course that taught at MIT. So lots of information. So having a existing C contest, winning entry to a model, you're tainted by the fact that people talk about it. But your new code, if you present it to a model and the model says, yeah, this is obviously maybe you need to do a little bit more just to sign. But don't expect the model to produce code like this. The people that wrote these programs put a lot of effort and skill. They are masters of C language and are masters at presenting it and getting it into a small chunk, like that 750 byte LM inference engine. I don't think any model anytime soon is going to be able to produce code that good. So take it we will. It's a tool, but not a way to probably win the contest. So I would say I'd ask saying this show has been produced on our Favorite Universe channel. We do plan on producing future shows on this channel. So after the hiatus, we'll have shows. We're going to go back to some of the really amazing winners of the C contest back in its 40-year history, and have shows not long as this, but a show per for entries. And if it turns out that you're a winning author and available and want to come on the show to talk, so for example, for Leo here, who has 2 amazing winning entries, I hope to be able to invite him onto this show where we take a given show, a couple of minutes, and get him to talk about his entry and what he was thinking at the time, a little background stuff, so you can better appreciate the winning code.
Yeah, you can reach out to me or Landon on Discord too to arrange that if you want to.
Yes. Because Leo has some fun tales to tell about his submissions.
Leo. He's on there too.
Or other people, right? So if you're a winning entry, winner author, and you've won in the past, please contact us, because we'd love to have you on a show to talk about your entry. You could be off camera or on camera if you want. And meanwhile, we'd ask you, could you please click the like button if you've been entertained by this, and also click the subscribe. When you click subscribe, it's not like you're subscribing to something you have to pay. It's free, and that subscribe is really the bad word. It's really saying I like this channel. If you subscribe, the algorithm will say, yeah, I should show this to other people that are interested in coding. So please click the like button. Please click subscribe. That'll help us a lot. I also mentioned that we'll see on the new web page, there's a social media page, and we have there a set of not only social media stuff where we have stuff on Discord. There's a Discord server you can click on and join the Discord server. Especially if you're a winner, you can get the winner IOCCC winner special badge. We announce stuff on Mastodon, and of course we have the YouTube channel.
And please, any of the winners that don't have a winner's badge, just reach out to me on the Discord to the admin, and I will get you the winner's badge.
Yeah, at admin on the Discord server is David. That's one of his many talents, is managing Discord servers. So you want your Discord server managed well, you can hire David, as well as producing stuff. We do have to thank people, which we're going to go to an intermission after the second intermission, where we're thanking people on the screen and fun graphics. We'll come back and do a Q&A. So hang around, because we'll have a Q&A on that thing. But I'll mention as well that we do have a Patreon. We have a Buy Me a Coffee, and also GitHub sponsor. And we want to thank, you'll see in there, if you're one of those people that's supporting us, that will thank you, because your patrons helps pay for the services and software necessary to run this contest, as well as to pay David, because he's a professional producer of shows. Some of the problems we had are on my end, not his end. He is a really professional at this sort of thing, and you can hire him to do some really amazing skill stuff. The graphics he did, the music he composed, the stuff. I don't know, David, how many triggers was this particular thing approximately for the show?
Well, let's see. Just for the show. 158 different logic program triggers for this show.
So imagine putting on a play and you have 158 signals to the cast to come in and do all this digital stuff. Pretty impressive stuff.
Not only that, but essentially 160 cast members plus all the additional assets. It's a pretty complicated show.
Yes. So thank you very much, David, for this. Again, links in the description below in terms of patrons buying my coffee GitHub, as well as our social media stuff. Reach out to it after the vacation. We'll come back on Discord. If you find bugs or misfeatures or typos in the 2024 directory, issue a pull request and we'll look at it. So without further ado, shall we have this intermission afterwards? Hang around because we're going to have a Q&A with the chat. And anything else before we have our intermission?
I think we can intermiss right now. Let's do it. And we're back.
All righty. So hopefully people have stuck around for the Q&A. We've been informed that there's 2 directories that are inverted, and I am in the process of correcting that right now. So while you get your questions ready.
That was the first thing that was going to go up on screen. See, look at that. You can see what is going on.
So while I'm fixing that, that's a fairly easy thing to do. These are 2 pieces of code that are there. So it is going to be the Strat and the and Mackie are inverted. There, let me do that stuff. And while I'm fixing that, because that's important to
yes, please send your messages in the chat, and I will magically make them appear to get answers. And while that is happening, there is a first question already from earlier that I think you guys can answer. And it is this. From Sir Wumpus. It says, with 2 judges now, how do you break ties?
This year, we had to include both entries if they were in a very contentious ties. But typically, our judging is not binary, but on a sliding scale. So there are not that many exact ties. So we do not go to thousands of a point, but we go to tenths of a point.
And I'll say that what we focus on when we do individual scoring of a particular type of score is we focus on the areas where there's a large difference. And if so, we discuss it. Not that one's right or wrong, but sometimes one person sees something the other person doesn't, either positive or negative. And so we focus on those areas of disagreement because that's something important. And we come to a consensus, and we'll revise our scores based upon new information back and forth. And at the end of the round, we've converged on scores that are pretty close to each other. But that's a good question for that as to how that's done.
We have a question from Devin Gilligan, who says, have you ever received an entry that was so obfuscated that even the judges couldn't figure out how it worked?
Yes.
That's how you win.
Well, we don't know how LLMs work, and nobody knows.
There's some mysteries in some of those pieces of code. I would say probably the submission that is probably the one that is hardest to get a handle on was a piece of code that produced an MD5 hash, and it uses entirely floating point arithmetic. It calls things like trig and log functions, yet if you know MD5 algorithm, all the bit twiddling and XORing and so forth, it does it all in floating point correctly. And we know what it does. We have an idea about how you pretend you have integers in bit arithmetic with floating point, but the details are just, yeah. So yes, there are things where there are mysteries still to this day with some of this code. And I say it is like this thing with that LLM entry. There's some stuff there that is a challenge. That is to figure out in full detail.
And we see General Stripe says, will you accept new X11 entries the next year?
Well, as far as they compile and
Yeah, there you go.
Yeah.
And we have a question from Sir Wumpus that says that he wants to know if food bribery is still involved.
Well, now we
It's a
are
little bit
judging remotely. Yeah.
It is really remotely.
No.
We could send each other chocolate and so forth. But I would say the judge bribing is done in the in between each other. External bribes don't work, and we've had to use you have to use virtual stuff. Leo used to bring really fun chocolates. I'd bring interesting code is stuff for code bribing as well. Those are really kind of important for that. But
yeah, is there any stories that you'd like to share with people while we're waiting for some other questions about the judging this time around?
Well, I think there were at least 2 8-hour Google Meet sessions, so that all the preliminary rounds were very long and involved, and I think it took more time than we spent judging things in person in the previous years. So in the previous years, there were like probably 2 weekends and maybe a couple of Friday nights. And this time it was 2 weekends and probably 2 more weeks, almost daily nights for a couple of hours or 3 hours each. So that was quite involved. Yeah.
And part of the thing as well is that there is things where we'd have a case where we would get into a round, we have the ones that we think are staying behind, the ones that are moving forward, and we have a pile in the middle. And some of it was a matter of like, well, we're not sure about this and this and this. So we did so we had to go off and think about it, come back and see if we can get our confusion down to a reasonable level.
And we had somebody who said, so the IOCCC is mainly food for thought.
Yeah, for sure.
Yes.
Yeah.
Yes.
Yeah.
And I say I'm right now doing the set here because what I realize is that the Serdot directory should have Anders and Anders should be Serdot. I've done the switch between the two, and now I got to go and do the build.
We have a question in from Sir Wumpus that says, "What happened to your third judge?"
We had a person that left, resigned, and we wish that person success. We've had judges in the past that have worked with us and have moved on, and this person did move on, and we thank them for the years that they were participating. So,
quite a few years and quite productive. Yeah, I'm saying that there were quite a few years and quite productive. We thank him for his hospitality, because we were doing that in his house for many years. Yeah.
Yes. So Sebastian Mackey says, I'm a little bit worried about the LLM entry. You have to download a 7 gig file to make it work. Doesn't this somewhat defeat the purpose of the challenge to also be lightweight? I can answer this one. It's the inference engine that's lightweight, and it's remarkably tiny. My understanding is that you could plug whatever model. That's just the one that they pointed to get it going. But it's the fact that it's able to do the inference that's the impressive bit.
And I think, Leo, your idea about coming up with that minimal Hello World model would be something that might be something small enough that we could include in the code.
Right. So strictly speaking, it was a little skirting the rules, because it didn't do anything interesting without the model file. But as far as it didn't crash and just said that the file doesn't exist, then we let it slide.
Because that's what it does when you don't have a model file. It looks for a model, doesn't find it, and says no such file. So in that way, it does something. Not very interesting, but if you give it a model, and I think if someone was able to build a Hello World model it was small enough that it could be included with the code and produce the proper results. By the way, right now I've switched those two directories, unders and the set. So I'm doing that. I'm doing the switch right now, and we'll have it up on the directory very soon. So back, other questions?
Yes,
I don't know. Yes.
Do you see the IOCCC embracing other language or staying C only forever?
Well, well, I think some people did ask us about C++ many years ago, and we said that if somebody is willing to start a obfuscated C++ contest, well, let them do that if they want to. But we are sticking by C for a while.
Yes. This is a C contest. And so it is C. And that's an important thing to understand, that it's really about the C code, not about the mathematical algorithm. So having an obfuscated mathematical computational algorithm is not as interesting as obfuscated C. That being said, if you are a language aficionado and want to start your own contest for your own language, we'll actually help you. Contact us. We had people that I think it was either Python or Perl that came out, reached us. I think it was Python, and we gave them some tips on how to organize a contest and some of the details behind the scenes necessary to do successful stuff. So if you want to do Rust or Go or Java, one of those things, contests, you're more than welcome to do that. And if you want to contact us privately for some tips on how to set up such a thing, we'd be very happy to help you do that.
We have you ever spotted entries based on style?
We suspected style. There's some people that have kind of a characteristic style, but go ahead, Leo.
No, so we usually give them a benefit of a doubt because people can imitate some other people's style just as well. So we cannot be 100% sure who the author is just based on style.
And I try not to think about who might have written this entry when I'm judging the entry based on its own merit. And I'm also recognizing that some people learn from previous winners and do things based upon that foundation. So I can't always assume, oh, this is someone who is doing accented characters. I can't assume it's Anthony C. Howe. It might be somebody who thought Anthony had a really good idea and is doing a new piece of code. Or it could be Anthony fooling us to do it again. You never know.
Right. But then again, entries which are quite similar to previous winners tend to get lower score than completely original entries.
Yes.
Sir Wampus says, all of us are getting older. Do you see handing the reins to younger blood?
Yes, at some stage, I will have to end up retiring for that. That'll have to be the case here. And yeah, it'll have to be, I guess it has to be the case for that.
But not soon.
Well, like, who wants to be the Ken Jennings of IOCCC?
Yes. But at some point it will happen.
Landon, fix it later.
Yeah. Yeah. So one of the prolific winners who is tired of writing new entries may volunteer to become another judge.
Yeah, it's the tricky part, right? Like there's some pretty great entries in here, but then they wouldn't be able to enter anymore. They'd have to judge the other entries.
Yeah. Judges are not allowed to win, and if a judge entered a submission and we opened it up and saw it was a judge, they would be eliminated from the final round. It's not fair. It would not be fair for a judge to. But that's the thing. Is judges can't compete. They have to be able to do their own work.
Yes.
And you have to have a really good. You have to look at code and try to be good at deciphering code. It does help you in dealing in production code where people write code that's not so clear. You look at it and say, that's a bit obfuscated, but you shouldn't be obfuscating your production code. So this is meant to be a safe forum for obfuscated code. Don't program like this in real life. If you look at my code in real life, it's very boring, heavily commented. Even when I'm doing a demo, I start with comments. I start with well-written code, literate code, to something that is dear and dear to me. This is the whole ironic point of the contest. Is this code works. All these entries work. They work as advertised. But many of them are nearly unmaintainable.
They don't seem like they should work. Like the Doom game. That doesn't seem like it should work, but it works. And I mean, Doom runs on everything, right? I shouldn't be shocked. I've seen Doom running on a birth control test. Imagine if someone just got done using it. Be a really weird response to get from a birth control test.
Yeah, but I say it's not about bring in another judge, but recognize that person would be out of the running, and such. So there's a penalty for being a judge, and you're subjected to lots of code. It's a very intense time to look at this code, and you have to be able to stretch your mind and come up with an interesting prize. So, by the way, how many?
You need to be able to speak Canadian, eh?
Oh, that's true too. How many winning authors were in the chat? Do we have an idea?
I feel like a good number of them. I saw them float by. There's a couple that have different names in the YouTube chat to what they have on their entry. But I think I would say even a few more than that. But yeah, quite a few. There's a few I don't think I saw, or at least they didn't raise their hand. Were you, Landon and Leo, planning on going to hang out in the Discord for a half hour or something after the stream and see if anybody wants to just chit chat?
Sure.
Okay.
That would be the case for that, for those things. Like I said, that would be fun to do. There is maybe say you could post to the chat a link to the Discord server.
I believe it's in the description, in fact.
But you could also post it to the things so that people could click on it.
I can do. It will just take me a moment to grab it.
And I apologize for the swap of the two directories. I never thought about checking. It checked if it was concurrent, but I forgot to check that the right directory name was under the right person. So as I said, the directory itself is coherent. It's just got the wrong name associated with it. And so we'll fix that real soon.
Okay, I will put the link to the Discord in the chat momentarily. I have it now. I need to find the window. You have no idea how many windows I have to have open right now. It's a crazy thing.
This is a pretty intense production system that David has pulled off. This is no mean feat to do all these entries and all of these dangly bits and cast characters and weird stuff. And I apologize on my side, my laptop with the line drawing thing, or that actually was an iPad, the app was having problems. I had to reload it. So I apologize. That's not David's fault. That's my fault. So
it's okay. I caught it once I realized what was going on. So I see a thanks for fixing the name from Sebastian Mackey. Let's see. Do the judges have to be in the same? Here we go. So do the judges have to be in the same city, or could they be remote?
No. We are probably about 1,500 kilometers apart.
And in 2020, we were remote. Yes.
And
in 2020, we did all online.
Yeah.
Yes.
So this is the first of the IOCCC actual audio video presentations. Yeah. But we'll be doing breakdowns and plus our favorite universe as well. So
we have to thank, because some people in Discord had suggested, they talked about the fact that the early IOCCC stuff was done as a BOF or Bird of the Feather session at Usenix. And the tradition was that the Berkeley people, the CSRG people, would come in to their Birds of the Feather session and now talk about the next BST release. And the end of their release, then I would get up and present the winners of the International Obfuscated Sequel Contest. And back even in the 80s, it consisted of my printing out stuff on transparencies and using an overhead projector, because we didn't even have computers to digital project things. So I had to do this all by sort of overhead transparency stuff. But it was done live. And so people said, hey, can you return to the live thing? We hope you've enjoyed this live presentation. IOCCC28 will have a live presentation. Obviously, there won't be as unlikely to have as many winning entries. So the award ceremony will be shorter, but hopefully as enjoyable.
Yeah. And I guess with that, we'll see you guys in the Discord, right?
Yes, I think it's time to wrap things up.
Okay, well, in that case, then we wrap it up. I hope everybody's had a great time, and we will be hanging out in the Discord. If you'd like to join, the link is in the chat and in the description below. Have a great night, everybody.
Thank you. Bye.